Hello everyone, welcome back. My name is Saikiran. This is the first and foremost task in our AIOps series. I would request everybody, whoever is watching this video, please do watch the theory session first because there we have discussed what exactly is agentic AI and then what exactly is coding assistant and what exactly is modern context protocol, how modern context protocol is going to use the LLMs as the underlying object and pull all the information and give the accurate answer to the users. So all those things have been covered in the theory part, and from now using foundation model, using agentic AI, using coding assistants, we are going to do all these tasks on a soft note. These tasks, we are trying to do somewhere around 20 tasks if it allows, or else it may reduce, but not less than 10. Almost 13 tasks were approved by stakeholders from my previous environment, to be honest. So I'm going to show you what were all those. Along with this, I also suggested another 7, but those were not actually approved due to some budget constraints. All right. So make sure you are watching this and doing the practical. If possible, post this on the LinkedIn as well. All right. Let's start today's task. Let's not waste the time, as most of them know we do a lot of practicals instead of theory. But see, this is AIOP series, right? So I cannot jump directly onto this task. So it will give us a lot of confusion. If you do not want to watch the theory and coming here, that is still fine. But you should be knowing at least one cloud, the prerequisite, one like some of the DevOps tools like Terraform, Docker, Ansible, one CI/CD tool, on one Red tool, regardless of Azure DevOps, Jenkins, GitHub Actions, anything, and then finally Kubernetes. These three were very, very important, everyone. All right, because see, for example, when doing these tasks directly, I'll show you something called Bedrock. So again, you should not be in a confusion what exactly is Bedrock, because Bedrock is part of an AI layer. This is actually called a foundation model, right? And all of these, the underlying component, which is all of these have underlying component, that is large language models. So that's the reason why I ask everybody to watch the theory first and then come back here. I know watching theory is boring, but still would be appreciated if you're watching. All right, guys. First and foremost task today, which is GitLab code review bot. Before jumping onto the task, I'll tell you something in real time. We have two different pipelines. One is from the application side, and the other one is from the infrastructure side. All right, we were using GitLab there in the previous environment. So in the application pipeline, again, we do have two different pipelines. One is for continuous integration, and the other one is for continuous delivery. Let's not jump onto the stages and discuss everything. It's a waste of time again. That is a different session which was already happened in our DevSecOps series. And on the infra side, also we do have two different pipelines. One is module pipeline and the other one is deployment pipeline. See, this might varies to the environment to environment or to the organization to organization. Not every organization is going to follow the same rule. All right, because in previous environment we do have somewhere around 256 microservices, so the overhead is too hectic. That's the reason why we have isolated each and everything. So, so here the reason why I'm explaining all these things were, see, for example, let's say we have somewhere around 40 plus modules. Our S3 module is alone does have somewhere around 2000 plus lines. Let's say every day we'll be having some heads up call, and every once in a sprint we'll be having a call with all different teams. We have 6 different teams there, and they are going to come up with different requirements, because 45 developers we have, none of them have edit access, none of them have delete access, none of them have create access. Everybody does have view access only. So we have 47 AWS accounts. So for all these AWS accounts, these 45 developers does have only view access. They can't create, destroy, or edit. So once the application has been designed, they are going to come with some requirement that, for example, say we need a GitLab runner. All right. And we need an S3 bucket. So the moment they say S3 bucket, I'm going to check the storage retention period, like how many days they wanted to keep this storage, and any other any other third party tool or any other like an API gateway resource or something is trying to access this bucket. And also I'm going to check on the replication as well. Maybe some questions will not be addressed by the developers. You have to take your own decisions by understanding your policies and the architecture. Let's say if a person comes in, a developer comes in and says, Sai, I need an S3 bucket. All right. So I have to go back. See, most of the time you're going to use automation itself only, which is the very famous tool Terraform. So we also use Terraform very intensively, everywhere almost. We don't usually do any manual changes, but most of the time we are going to use Terraform itself only. So let's say if I wanted to create one more bucket, first and foremost I'm going to come back to my module and I'm going to create a new branch like this. Okay, 4 3 2 1, this is my ticket name, and I'll simply say colon future S3 bucket or something. I'm going to create one branch like this on top of this S3 repository, because this repository is under this Terraform Cloud modules, right? So I'm going to clone this to my local repo and I'm going to do all the modifications, whatever I needed. All right. Let's not discuss about those changes right now, but I'm just saying I'm going to do creation of bucket, enabling replications, names, different whatever we have, like lifecycle rules, storage retention policies, blocking all public access, adding some custom policies to the S3 bucket and everything. Right. Once after it is done, then I'm going to create one MR. All right. I'm going to create one MR and I'm going to assign this MR to one of the senior member. Okay, he's not an architect, let's say a lead or a platform owner or someone, a lead position guy. So what this person will do is, whenever I push this code, the branch whatever I've created, whenever I push this code to this branch, immediately what will happen is in the background our pipeline will trigger. And our pipeline will trigger and it will go through some stages like Terraform init, Terraform plan, Terraform format, validate, plan, apply, and then destroy. Listen this carefully. So here we'll be having 6 stages: apply and then destroy also, because whatever changes I have made here, so that should be matching with the existing code. The moment it is applied and then the moment it is destroyed, the pipeline status will be success. Everybody knows this. You'll be seeing everything in the green. Then what my developer will do is, my developer will, the moment I assign this MR to this guy, I'm going to notify in the common teams session and I'll ask him to review the code, right? MR, review the MR, merge request or PR, you say pull request. So this developer is going to watch the pipeline status first, whether if it is passed or failed, and then once it is passed and if it is all okay, then he is going to approve. This is the common process we are going to follow. But I'll tell you an example here. Let's say accidentally I push some API keys here. All right. Or name should also be, shouldn't be called directly. Everything is hard coded. All right. Name and then whatever meta arguments were there, we are going to hard code everything. So just in case if I'm pushing some access keys or secret keys, it won't happen. I'm just saying. Or any DB URL or DB password or some XYZ resource. I want immediately a bot. This bot supposed to identify this and immediately comments on my GitLab review before my developer checks it. This bot should come into the picture immediately and then it should comment on my GitLab comments that XYZ security issue was there. You have pushed some XYZ, for example, access keys or secret keys or anything. It should involve, that bot should involve, and it should write a comment in the GitLab review immediately. So previously, what used to happen is, let's say if there is 2,000 lines of code, developer can only just go back and check whether uh, if there is any like whether the pipeline has been passed or not. But he cannot review all these lines again, right? So we have we have a by default feature if you are opting GitLab if you're opting GitLab Dio. GitLab does has this Dio feature. Dio meaning it's part of agentic AI where you can set up a reviewer and then you can allow it to review the code. But the problem is some organizations will be having managed managed GitLab accounts, and some organizations will be having self-hosted, meaning GitLab runners. All right. So in that case, this feature is not every time possible. Again, you have to pay some extra money for the premium, which is not okay for me. Ultimately, our client is going to come back and ask, what is the reason you are going for the premiums again when your GitLab account is self-hosted on somewhere AWS or Azure or GCP cloud. So in that case, these strategies were needed actually. So in today's session, what we're going to do is we are going to create a bot. So in the background, we'll be having something called Amazon Bedrock, and this Bedrock is going to use a Haiku model by Claude or Claude, whatever you say. So so this is going to before this, my Lambda function will invoke. My Lambda function will invoke, and then it's going to invoke this Claude model from Bedrock, and then automatically this is going to read my code and identifies if there were any security issues, and it's going to add the comment in the comment section on the GitLab review. So it's a very big process, not an easy process. I've just told you directly that Bedrock and then Lambda, but in between we have something called API gateway, and also we are going to create one GitLab account, and also Lambda functions we are going to create, and also IAM roles. And then IAM roles we are going to assign because Lambda does have some basic execution role, and also Lambda should um, uh, invoke by Bedrock also. So that's the reason why our Python logic will be uh, in such a way that it's going to invoke by Bedrock resource and call the Cloud Haiku model. Um, so all these things were interlinked actually. I'm going to explain in a detailed way because each and every step I've written in a step-by-step manner. Let me show you that. So these are the steps we are going to watch and do it carefully. All right. So I hope you understand the gist of why am I creating a bot for my code review, just in case if someone tries to push any GitLab URLs or not URLs, Git database URLs, database passwords, API tokens, access keys, and secret keys, then immediately my bot is going to involve and it's going to a fraction of seconds. You're going to see when doing the practical. This bot will involve when write a comments, then immediately I will cancel the merge request and I'll do necessary changes, and then I'll proceed accordingly. So that's what we are going to achieve today. So let's go and do the practicals, everyone. All right, here is my console, everyone. So first and foremost, I'll open my document again. You can read the Y factor here if you watch this document carefully. Everywhere we have written the Y factor. See why we are doing this step. The gist of following this step. I'm going to delete this token later, not an issue, because this is a temporary token itself only. And then if you watch part 2, everywhere we have written the Y factor. Please do read it if you do not understand why we are doing this step. All right. Even if even if someone doesn't know how to what is DevOps or cloud or something like that, they can simply follow this document and deploy whatever we are trying to achieve. So that easy this document is. So please do follow architecture and everything. Great. Let's start. So first and foremost, we are going to deploy this Terraform file. Just say new terminal, and I'm in the AIOps series itself only. So this is 01. Okay. So I should have my GitLab files here. Okay. TF file and then bot. All right. Now watch this carefully, everyone. This is whole Terraform file. Again, Please go and just read it what exactly is there. I'm not explain now. But here in the user data, it's going to take some time. All right. Please do not start the server immediately and then log in and try to access the URL. It won't work. In the background, it's going to take some time. So I'm gonna say before Terraform init, I would request everybody don't use access keys or secret keys and just run AWS configure. Instead, just say AWS login hyphen remote. Mine is already logged in, that's why it is showing like this. So for your case, the moment you enter this command, what will happen is it's going to give you a unique HTTPS URL, hyperlink URL. Just copy that URL and paste it in the Chrome tab, and then it's going to ask you what access you need. You can select a root and then give the access. So it's a temporary token where you're going to have access to your AWS account temporarily, and you can deploy this Terraform onto your AWS cloud. All right. So just say Terraform init and then Terraform apply. This code is working. That's why I'm giving this the apply hyphen auto improve directly. So one thing what you have to change is make sure that you're changing your key name here. All right. And also make sure that you're taking T3 medium and above, not T3 medium and below. It won't work actually. All right. So this is going to deploy in the background. What we shall do is just go to the Bedrock first and then Amazon Bedrock. So select any model, whatever you wish, but I'm going to select um, something called Anthropic. So let it load. Loading. It's taking so much time. So under Anthropic, we are going to select Claude Haiku model, for example, anything. So let's say you're randomly selecting this, okay? Any model you take, just select this, and here you're going to get an option, guys. Submit details. Just click on it and submit the details, random details, whatever you wanted to give. Because see, in the background, we are going to use these models. So if you're not submitting the use case details, then it won't activate. The moment Lambda tries to invoke this Bedrock model is not going to activate. So first submit the details. You're going to see the option here. I have already submitted. That's why it is not showing here. So submit it and then come back. That's it. Nothing else you have to do. And then blindly follow whatever I'm showing. So first and foremost, let's see how far it came. It's still under init itself only. I'm going to pause the video for some time. Let's wait for our Terraform to deploy. Until unless Terraform has been deployed and then GitLab is up and running, we cannot proceed further. All right. If you watch here carefully, the GitLab has been deployed successfully. So now let's copy this URL. I'll just copy this and let's go back here and paste it. So you have to log into the GitLab EC2 instance because you need to find one root password there. So let's log into the GitLab EC2 instance. Go to the dashboard, instance. I'm in Asia Pacific, Mumbai. Just move to the North Virginia because just say root and let's connect to this EC2 instance. And I have the command here where exactly you are going to find the password. So if you scroll down a little bit, it will be here somewhere. Yeah, here it is sudo cat. And then we can just paste this. So this is my password. I'll just copy it and paste it here. Done. First step is completed successfully. We have successfully created this GitLab account. Now the second step is generate the project access token. Just read the Y factor here. Our AWS Lambda function needs permission to read the code differences and posts the comment back to the merge request. We use scope project access token instead of personal token for security. So later our Lambda function will be invoked and it's going to read the code differences. So for that, we should have some handshake method, right? For GitLab and then this Lambda and then Bedrock and all those stuff. So for that handshake method, we are going to create one token on the GitLab side. So let's do it. Click on acknowledge and then acknowledge. So from where you have to create the token. But before that, first you have to create one project. Just click on create project. So here it is. I'm going to name the project as Finance API Service. Create blank project and just select root here. API Service, private, initialize repository, and then just click on create project. So project has been created successfully in step one. So now generating the project access token. So inside this repository, go to the settings and then click on access tokens and give the token name is AWS AI bot token, and the role should be maintainer and scope should be this API access, read repository access, and then write repository access. Settings, access tokens, add new token. My token name is this, and the role is maintainer and API read repository, write repository. Let's cross verify. Role is maintainer, API, read repository, write repository, and simply click on save. I mean, create project access token. Copy this carefully because you're going to see this only once. So just copy this and come back here and paste it. So later we are going to delete this. So I'm just saving it here. Also, on top of this, you also have to copy the project ID, guys. So I'll show you where exactly the project is. Project ID is click on Finance API Service and click on these three dots. I'm sorry, these three dots. See, this is your project ID. So mine is what this is the very first project we were doing. That's why it is one. If it is two, two. If it is three, three. Likewise. So this is my project ID. I have mentioned my project ID here, which is what later we will be having a small work with the project ID. That's why I've taken the project ID as well. Done. Successfully completed the creation of a GitLab account and then generating a token. Now comes the important thing, which is AWS IAM Bedrock setup. So create the Lambda IAM role. Go to the AWS console, IAM roles, create roles, trusted entity type, AWS services use case Lambda. Click next, next, and then give the policies as Lambda execution role and then Lambda Bedrock full access. See, Lambda execution role, why am I giving this policy is once after your Lambda function is invoked, it's going to generate some logs, guys. So those logs will be stored in the CloudWatch log group. And by default, they don't have the authentication between them. So this AWS basic Lambda execution role will be having those specific policies where it can go and store all the logs. And as we know, our Bedrock full access, why we are giving is it's an foundation model where internally it's going to use a cloud model, and it's going to check the differences in our code and understands if there were any security issues. All right, now let's start. Let's go to the IAM from the AWS console. Just say IAM, open it in a new tab, and just select IAM. IAM roles, right? Yeah, IAM roles, and just say create role. AWS services, select Lambda, and click on next. Now, Lambda basic execution role. Lambda BASIC. This one, Lambda basic execution role. See here, logs, create log group, create log streams, and then put logs. So this and then Bedrock full access, Amazon Bedrock full access. These two we need. The role name is GitLab AI bot role. Fine. Two permissions were there. Good. Now I'll just simply click on create role. Fine. This step has also been completed successfully. Now, part 3. Create the Lambda function. This is the important case. Go to the AWS console, Lambda create function, author, and then my Lambda name is this. And we are going to select the GitLab AI bot role as an execution role that we have created in the above step. Correct? So just say Lambda, and then I wanted to take Python 3.9. 3.9 has been expired, I believe. Let's see. So this is my Java. Yeah, 3.9 is expired. I'll take 3.11. Um, and then permissions, author from scratch, runtime, additional settings, select execution role. So the role which you have created just now is GitLab AI role. Here it is, GitLab AI role. So AI bot role, and then I will say save it. Role was there, and simply click on create function. Also, once after the function has been created, make sure that you're increasing the timeout, guys. By default, it is 3 seconds only, which is not sufficient for us. Just keep 1 minute 3 seconds. That is okay. And then save. Good. We have successfully completed this step as well, step 4. And now step 5 is important step. Do it please carefully. Hard coding tokens in the code is a massive security risk. We inject them. We know this already because lambda function does have environment variables where we are going to store all our keys. For now, we are going to store our GitLab token, project ID, and then webhook secret. All right. So just copy this and make sure you're doing it this step carefully. Go to the environmental variables, click on edit, click on add environmental variables, and then paste it. Add one more. So what was the ID here? This is just a key pair. Copy, make sure there are no spaces, and webhook secret. Nice. What was the token? If you remember, we have created one token, GitLab token. It's in my, here it is. I'll just copy. I'll paste it in token here. GitLab project ID is one, and a webhook secret. So later we are going to create this on GitLab side as well. So now we are going to give this password superstring 123. Just paste it and then save it, guys. Just see any spaces were there. Nothing was there. Here, friend. Okay, all good. Just click on save. So keys have been stored successfully. Now what? Write the AI bot logic. So this is our Python function. If you do have time, please paste it in any agentic AI or any tools, AI tools, and then understand what exactly this is doing. On a high level, this is going to invoke the moment someone raises an MR, and it's also going to Lambda function is also going to invoke the Bedrock, and the Bedrock is going to check the differences in the code. So what we're going to do is just go back to your Lambda function code, and then just remove the code whatever is there here. Just say uh, anything happened. Just remove all the code and paste it. Just click on deploy. So you should be seeing here, yeah, it is updating the function. GitLab AI code, yeah, successfully updated. General configurations, time and everything was same. Good. So we have also finished this step as well. Click deploy, go to the configuration, general configuration, edit, increase timeout. Yeah, we have already increased the timeout here. And now the important step, which is API gateway. We are going to keep some post method because our Lambda function should post some comments, right, in the GitLab review. So for that, we need the API gateway as well. So expose the Lambda to the internet. GitLab needs a public URL to send the webhook payload to. API gateway acts as the secure front door of our Lambda. So go to the AWS console API gateway, then create API, HTTP API build, integrations, click add integrations, Lambda, select our Lambda code, and the API name is this. Okay, just copy this, go back here. This is a one sprint activity, guys. You can do it in one sprint, but ideally you can do this in one day actually. Not one day, 1 hour is sufficient. Um, if you do have the if you do have all the configuration files and testing everything was done, but still sprint is okay. HTTP API, click on build, and my API name is this API webhook, GitLab webhook API, and integrations, add integrations, and I'm going to select Lambda. So this is my Lambda function, the one which I've created. Select it, click on next. Configure routes, as I said, we are going to post the comments. That's why it should be post method. Resource path, select this GitLab AI code review, and this should be slash webhooks. Just go back and check. Paste the API gateway URL. No, here it is. Go to the AWS API gateway. So configure post route path is slash webhook. Okay. So this is the stage. I mean, this is the resource path. Integration is GitLab AI code reviewer. Click next, next, copy the URL. Okay. Understand. So it's not webhooks, it's webhook. That's it. Slash webhook. Post method. This is the integration path and click on next, next, create. So once after this has been created, make sure you're copying the URL, token URL. See, click on the stages, click on default. You're going to have one invoke URL here. So copy this invoke URL, go back to your document, and I'm going to paste this here. You have to add slash webhook at the ending. Okay. Please don't forget, save it. So this is my new URL. So GitLab webhook configuration. This was also done. Connect to the GitLab AWS. Yeah. Now part 5. Connect to the GitLab to AWS. We must tell GitLab to notify our API gateway. Yes. So go to your GitLab project, settings, webhook, add new webhook. Let's go to the GitLab project, settings, webhooks, add webhooks. So name is, I'm going to give bot review. URL is the one you have copied just now. Okay. The one you have, see this one. This is my URL. I'll just copy it for you and then I'll paste it here. Okay. And we don't need to generate the signing token. If you remember in the Lambda, we have already created one token, and that token name is this superstring 123. Super hyphen secret hyphen string 123. Nice. And then I'm going to paste it here. So, so on merge request, this event should be there. That's why I'm selecting on merge request, not on the push events, right? If you find anything is check mark, just uncheck everything and select only on merge request. That's it. And simply click on add webhook. Finish. The webhook part is also finished. Now if you test, it will fail because there were no merge requests currently. So see, hook execution failed. Ensure the project has a merge request. It's fine. Currently we don't have any kind of merge request. All right. So this step is also done. Now test the connection we have tested already. See, I have written here. Hook execution successful HTTP 200. Initially, it will fail as it is the first MR. Please ignore. So let's ignore it. Don't worry about it. And real-time production test. So this is how we do smoke testing. So what I am going to do is I'm going to push the vulnerable code wantedly just to see if it is really giving me the adding the, my Bedrock is adding the comment or not. Okay. So I have just copied this vulnerable code, and now what I'm going to do is I'll just go back to my GitLab. So I will just copy my this GitLab code, enable the terminal. I'm going to just open bash and I'll say git clone and then paste it. So it's going to ask the username. Username is Saikiran PI, and the password, if you remember, the password is this. No spaces. And it's going to connect. What happened? Incorrect expired or import scope access denied. Maybe I have, unless Oh my god, so many files were there. CD, what was the repository name? Did I went into the repository? Finance API service, yeah. Git clone, paste, and then, oh, sorry, this is the token, right? Git clone. So this is my HTTP, yeah, this is the one. Paste it. So here it is root. Previously I've given the wrong username. All right. So now let's copy this, come back here to my, paste the password and enter. So now it's going to clone. I will log into the directory and I will say git checkout hyphen b future. This is my new branch. Okay. So feature DB is my new branch. So now what I'm going to do is nano test.py. So I'm going to create this and I'm going to post the vulnerable code. What deadly? My vulnerable code is here. Just copy this and paste it. So just give Control X Y and then git add dot git commit hyphen m add should be in a small letter. First, ideally it should be like this. Feature DB add test commit git push horizon. So to this branch, I'm going to push. So copy this and then paste it. So it has been pushed successfully. If you go back here to the branch merge requests, so see it says create merge request. So I'm going to click on it, and this is fine for me. And in the description template, anything not required. So I will just leave it. I'll say this commit is to, or else I'll simply say smoke testing. Smoke test, and then I'm going to assign it to one of my developer or lead or someone, and then scroll down, look the changes whatever you have made. So this is the vulnerable code actually. Okay, we are trying to fetch something like DB password and then username and all. It shouldn't happen ideally. So just say create merge request and watch this carefully. The moment merge request has been created, a new command will be added immediately. So let's wait to see. It says error access did an error occurred, access did exception one invoke model. Model access is denied due to invalid payment instrument. A valid payment instrument must be provided or our AWS subscription for model cannot be complained. No, this does have a, if you have any billing issues then it won't work guys actually. I updated the billing details already. I don't know what is the problem. This is not the current bill. Payment preferences. See, payment was there. I have enabled the payment method already. Why it is okay? Let's use the agent here. Let's see. GitLab. Gemini Flash. Let's see what it says. See if it works or it also throws the invalid. We were taking the on Lambda function. We are actually taking the cloud 4.5, I think. We should see if the AI is API. US Anthropic Haiku 4.5. Yeah, 4.5. This model is working actually. I tested, but not sure. Let's see what Gemini is going to do. Open a billing account and support case. What if it still fails? Okay, it says retry invocation. Allow verify card type. Strict requirement. Credit card required. AWS Marketplace subscription. Usually reject debit cards, UPI, and then oh, this is the issue. Okay. Yeah, fine, guys. It's okay. It is working. If you watch in the background, it is invoking. See, I should have tested in the different account. This is my Sandpit account. I do have my dev test account. I should have tested here. So we won't be able to see any issues. I did a mistake by starting it from the Sandpit account. It's still okay. Um, this is actually a temporary account. That's why I've not given my credit card details here. Instead, I enable the auto payment of this one. What should I say? For UPI. And here in the Gemini, if you see, it's saying it won't work payment preferences. So either it should be a credit card only. Then only it is a valid payment method. See how AWS is account stream and then these streams are playing. It's okay, but still, if you watch here, it is invoking. See the comments here. Actually, you're going to see one comment here. I should have taken the screenshot during the testing. I did testing on my dev test account and doing the video on this Sandpit account. But in your case, you won't see this issue. It will definitely show you an error here. Okay, and let me try one more time. Let's close this merge request. Let's see. I'll create one more and see what it will say. Enable e-commerce channel, open your card, open a billing account support case in the AWS console. No, not required. I know the issue. What if it still fails? Retry the invocation. Once the propagation window has passed, you can test if the issue is resolved. AWS Bedrock invoke model ID. And this CLI command succeeds without error. Your GitLab bot will immediately be working. Okay, let's test this. Let's see if it is AWS Bedrock runtime invoke model ID US Anthropic 4.5. Okay, so I will just copy this and I'll just open my Cloud Shell. I'll try manually, but it is an automated way only. But let's see if it is working. Then okay, or else I will stop here because we got the final output here. See, we got the final output here, so it's okay, no problem. But before that, I'm going to create one more merge request, and I will say create merge request. And if still says, see again, it says invalid payment instrument. That is okay, expected, not a problem. So I will just run it manually, paste it. Bedrock max tokens 100 message role. Okay, guys, it's fine. I don't think the issue will repeat for you. It will definitely work for you. Just do the practice. That's all for this session. So here it's going to identify that there is a vulnerability in this code, whatever you have pushed it by creating a branch, and then automatically this is going to add the comment here. Okay, so what we have to do first and foremost, go back to your Terraform, click on terminal, and then make sure that you are um, Terraform destroy. Terraform. See, this is, don't think that it is failed and ignore the practice. It is working as expected, but the problem is with the payment. Now we cannot fix that. It will take so much time. You have to give credit card details, a CVV number, and all those things, which is not really required. I hope everybody has been understood the flow and everything. Just do the practice. In your case, you won't see that issue because your records are already in sync with proper card details. All right, mine is different. Mine is UPI. That's why it is showing like that. Um, let's delete everything one by one. So first API gateway, select, and then just say confirm. Once this is done, just open Lambda. In the background, this Terraform is also going to delete our EC2 instance and everything. So just confirm, and then this is deleted, right? Lambda function is deleted, API gateway is deleted, functions, EC2 instance is also going to delete, and then you have to delete the IAM role. Go to the roles, select this GitLab role, click on delete. That's all for today, everyone. Do the practice and post it on the LinkedIn. I'll be watching. Please like the video, subscribe to my channel, everybody. If you're not subscribed, most of them were like, I know there is a lot of hate on me because I made videos private, because at the time the decision whatever I've taken is good for me. My video student went outside completely and most of the students got jobs. Almost 100 plus students got jobs in my mentorship sessions. So I'll see an alternative plan maybe in near and future once after this AIOps has been completed. Again, I wanted to do a lot of DevOps and then Kubernetes activities, but those I will plan to post it on YouTube itself only. But I'll see what is the secure way where by mentioning some watermark or keeping my face visible in middle of the screen or in the corner of the screen, something like that. But please do like this video and comment if you still have any questions, or if you wanted me to improve somewhere your feedback or something like that. Please put in the comment section, everyone. Thank you so much, everyone. Have a nice day. We'll see you in the tomorrow session. Bye bye. Hello everyone, welcome back. My name is Saikiran. In today's session, we are going to do one more activity on AIOps, but this time we are going to do it on the EKS, AIOps log detection and development. But before understanding what exactly this task and what were the services and what AI model we are going to involve, I will tell you what real-time use case scenario that we have faced during the peak traffic. See, we have somewhere around 11 EKS clusters. All 11 were not part of prod. We have three different environments. One is a dev test environment, and the other one is a pre-live environment. And we also do have one environment called prod environment here. All right. See, in prod again we do have four different clusters: prod A and prod B. Prod A is actually tipping its head to the live environment, and prod is the disaster recovery cluster. Likewise, we have one more application. For that also, it does have prod A, which is live, and prod B is the disaster recovery. All right. So let's forget about the ingress. Let's forget about how many node groups and all those stuff we do have. Ideally, we'll be having 3 to 4 node groups in our environment. Dev test it will be 2 or 3, pre-live it will be again 3, like prod it will be 4. So we have somewhere around 256 microservices. So out of this, I hardly remember more than 100 plus microservices were in communication with a database here, PostgreSQL database. All right. So during the time of Halloween festival, I remember in December, these microservices are going to communicate with this database continuously, and suddenly, you know what happened for this database? The connection timeout has been faced like HTTP 500 error. So during the peak hours, whatever microservices were in communication with this PostgreSQL DB, we have somewhere around again 10 plus, I think. 10 plus pods on this Postgres SQL. These microservices, whatever were there, those were out of max connections. Max connection limit has been exceeded actually. Okay, we have seen somewhere around 17 pods were failing. All right. See, initially we didn't know what exactly is the issue. Max connectivity issue, we haven't expected that issue is going to occur. Always we think about the auto scaling and then HP and pod scaling and all those stuff, cluster scaling and all. But max connection timeout for this DB just because other microservices were communicating with this Postgres SQL. To be honest, it's not in our expectations. You know what happened? We are only 6 members handling the entire environment from India, and immediately we opened Grafana dashboards because we have Grafana visualization. So here we entered some custom queries, not PQL. Sorry, we have entered some custom queries here. So the mistake what we did here is, in real time, if you identify that there is a pod which is no tolerance, like zero tolerance pod, you have to create some custom dashboards to this particular pod, and you have to observe it continuously. But in our case, we haven't created any kind of custom Grafana dashboards. Instead, we are monitoring everything at one place, and it took almost for us to identify what exactly is the issue for the next 45 minutes, because the error is very simple: max connection timeout, HTTP 500 error. That's it, nothing else. So we couldn't able to understand what exactly is the issue. So, however, we have identified that we have root cause analysis. We delivered it to the stakeholders and everything. We have resolved it ultimately. But the problem is, see, our environment is very huge. We have somewhere around 11 EKS clusters and somewhere around 47 AWS accounts and somewhere around 256 microservices. And we need to feed answers to somewhere around 45 developers, right? Because none of these developers does have any kind of delete, edit, or create access. Everything will be reliable on the cloud team itself only, right? Ultimately. Now, there comes this AIOps log anomaly detector. So, what exactly is going to happen here is, we are going to, let's say your application is generating 10,000 logs per second. Okay, it doesn't happen, but I'm just saying, unless it's a very big environment, this won't happen. Your application is generating somewhere around 10,000 logs. All right. And today, what exactly we're going to do is, we are going to deploy something called fluent bit. Fluent bit is actually a log aggregator. This has been discussed during the session of ELK task. We have done multiple tasks with ELK. So we are going to deploy this as a daemon set. We are going to take two node group, EKS node group. The moment you deploy it as a node group, this is going to deploy on two of the nodes strictly. That's the deployment strategies we are going to follow. So it's going to pull all the logs from the node groups, all right, and it's going to write to the Kinesis. So the reason why I'm taking Kinesis here is Kinesis is specialized in holding the live buffer logs. All right. So this fluent bit is going to write the logs to the Kinesis, and our Kinesis is going to invoke the Lambda function. All right. So what this Lambda function logic will be doing is, so if it founds anything like error or failed, so our Lambda function will also be invoking the Bedrock model. Again, the Bedrock is going to use an AI model here, that is GPT model. I'm going to show you what GPT model we are going to use. And the moment your Lambda identifies if any log contains error, failed, or warnings or something like that, your Bedrock is going to involve, and the model GPT is going to scan the whole exact error lines and understand what exactly is the issue. See, here in this case, it took somewhere around 45 minutes to identify for us what exactly is the issue and why it is max connectivity timeout. Likewise, imagine if you do have more clusters. For example, I've given an interview for the team mobile, so they do have somewhere around 6,000 EKS clusters, 12,000 nodes were there. All right. Likewise, on-prem, they do have 1,500 COPS deployed clusters, 3,000 node groups were there. Imagine the level of management here. So in such case, just in case if any error error occurs, then it will take so much of time for us to identify, first of all, from which account it is coming from and which microservice. And then we have to log into the pod, monitor from the rancher. Like, you have to run some commands and understand what exactly the issue is. So, following these methods, this Bedrock agent is going to, like, collect all the error lines and understands simply that, hey, Sai, this is the XYZ issue. Try to follow these steps for remediation, for resolving, or else. So this part, this second part, whatever we have discussed, this is going to send directly to our Slack message. So we are also going to involve the Slack webhooks here. So I'm going to show you everything practically. Then it will be easy for you guys to understand and do the practice. So let's go and do the practice, everyone, so we will understand it clearly. I forgot to tell you one more thing. I said 11 EKS clusters, right? So usually we do not have, we of course we do have Rancher and Prometheus. I mean, not Rancher, Grafana and Prometheus. But to be honest, we were not from the monitoring team. We don't monitor anything honestly. But we have something called Rancher. Again, even if you're using Rancher, it doesn't mean Rancher is going to show you directly. No, but still, Rancher is going to uh, manage your EKS clusters, where you can go and click on the cluster, whatever cluster you want to click on the particular node pod, and then you have to still run the commands. So again, it's going to take some time for us, right? So following such kind of creating such kind of system will be more easy for you to understand where exactly the issue is, and you can fix it as soon as possible. All right, so let's go and do some practicals, then you'll be understanding everything. So here is my console, everyone. Before coming to the session, I just deployed this EKS cluster. If you watch this Terraform file, so this has been deployed. Actually, it's going to take somewhere around 15 minutes. So before wasting time, I just deployed this cluster. This is straightforward. We are going to take two node groups only. If you come back here and if you go to the cluster and if you click on compute, see there are only two node groups here. So now if we go back to our step-by-step documentation here, just try to read the documentation before doing the practicals. If you see what exactly we are doing here, and also in each and every step, I have mentioned the Y factor. All right. So first and foremost, deploy your EKS cluster, and then first step, what we need to do is we need to deploy the kinesis. As I said in the introduction, this is specifically required because if you wanted to hold the live logs, so like somewhere around 10,000, 20,000 logs for buffering, then the kinesis is the best service to hold them. So for that, we are going to create the kinesis data stream for now. So why we need a highly available buffer? If our EKS cluster outputs more than 10,000 logs lines per second during a crash, so what kinesis is going to do? Kinesis is going to hold them safely until Lambda can process them. All right. Now follow the steps here. Console kinesis data streams, create data streams, capacity mode on demand, perfect for our unpredictable spikes. Click create and then save the ARN. This is my console, and just say kinesis. Just open it in a new tab so that it will be easy for us to, at the end of the session we can delete everything. Kinesis data streams, click on create data streams and give the name as EKS log stream. Select on demand and don't change anything, just leave it as it is, the default settings. Just scroll down and simply click on create data stream. So first step has been completed successfully. If you go back to the document again here, I'll just close this or I'll just minimize because this is not required for now. And in the second step, create IAM role for the fluent bit. We are going to create IAM role for service account. See, EKS create IAM service account to what cluster? To this cluster. My cluster name is my cluster only. And region US East -1. And then the name, you can give any name you want. I'm just giving a fluent bit. And namespace is logging. And we are going to attach one policy, and that ARN is this. Amazon Kinesis full access, because this service account will be having this specific role. And approve hyphen hyphen role name is equals to, you can give the name whatever you want, role name. So let's go and do that. Just copy this command and just maximize your CLI, and I'm going to enter this command. Just paste it. Click on enter. So it's going to take somewhere around 30-40 seconds time to create. In the background, it's going to create one cloud formation template if you watch here, and then it's going to spin up the resources whatever it is required. Service account and then this IAM role. Once it has been completed, make sure that you're doing the fluid bit deployment. If you read the Y factor here, fluid bit is ultra lightweight. See, we also do have something again, FileBeat, Heartbeat, FluentD. All these are actually called as log aggregators. We have discussed already during the time of ELK session. We did a lot of practicals on that as well. So FluentBit is, see, that's what I mentioned here. It is quite lightweight. If you wanted to take FluentD, you can also take that. But I'm just taking, this is the test environment, right? So I'm just taking fluent bit here, which is ultra lightweight. It don't see, it runs on every node. How it runs on every node? Because we are going to deploy this as a daemon set. If you watch this carefully, here it is. The deployment strategies, whatever we're following is daemon set. So let's understand this manifest file first of all. So this is the configuration of our fluent bit. I have named it as fluent bit config, and this is the configuration. Just go through what exactly we were doing here. All right. Again, as said in the introduction, we need some basics of Kubernetes, DevOps, and then AWS Cloud, so that you will understand such kind of steps very easily. And then if you watch carefully here, so in above we have created one service account, and the service account name is this fluent bit. All right, just remember that. Now if you scroll down, we were creating one cluster role. I can, you know what I can do, I can directly uh, take one node and give access to it directly, and allow it to access the pod, like, list the pod and watch the pod namespace and all. But that is not the secure way. The secure way is to create one service account, and for that service account, look here, we are creating one cluster role, and we were giving resource access only for the namespace and pods, just to view list and then watch. We were not giving any kind of edit access here. And watch here carefully, line number 124, we are binding this role. Cluster role alone can't do anything. We need to bind that role. All right. And just watch here carefully. If you see the service account, whatever access was there here, so this access will be applied to a specific service account, and that service account is FluentBit, which we have created above. Right. So that particular service account will be having namespace and pods, view access, list access, and then watch access. Right. And finally, this is the deployment of our fluent bit. We were deploying it as a daemon set, meaning each and uh, it's going, this log aggregator is going to deploy in each and every node. If you're taking node 1, node 2, node 3, how many node groups you're taking, those many node groups it's going to deploy. That's the speciality of the daemon set deployment. And rest all were common here. Again, I am deploying it in AWS region, US East one, and then these are the resource quotas and limits I'm providing. And finally, my logs gonna store in this location, var hyphen logs. All right, so let's copy this carefully, scroll completely up, and then just copy it. I'm going to say nano fluid.yaml, and then just remove. This is the previous one actually. So I will do one thing, just give Control X. I will delete this. Yeah, now good. Just say nano fluentbit.yaml again, and I'm going to paste it. Just say Control X Y, enter, and kubectl apply hyphen f fluentbit.yaml. Just click enter. If you go back to the documentation again, this step, which is step 2, is also completed successfully. This is going to take some time, and it's going to deploy. Now, what was the next step here? If you scroll down, yeah, now the third part here is the AI Lambda consumer. We need to create one Lambda function. Fluid bit of rebel error validating failed download OpenAI get HTTP US story case failed to verify certificate is valid proxy Heroku space.com not. If you choose to ignore these errors, turn validation off with the hyphen hyphen valid equal to false. Fail to download Open API. Open API get HTTP timeout TLS fail certificate. Let's see why it is failing. This shouldn't happen actually. Let's take our agent help and see if we can fix this. Copy and I will just Windows L. I think we can ignore this with this flag hyphen hyphen validate equals to false, but let's see what our agent is going to suggest. Because we have an agent feature here, let's not waste the time and we can jump direct. kubectl. Yeah, see, that's what I said. We can ignore this. You can bypass this local schema validation step and skip TLS certification check by adding hyphen hyphen validating fields and secure skip flags to your command. This tells kubectl to skip the local schema download and allow the certificate warning, deploying the manifest directly to your cluster. Okay, so this is a HTTPS certificate error caused by your network environment. What is causing your kubectl client is trying to connect to your EKS cluster API endpoint, but it is being intercepted by an HTTPS proxy, specifically a Heroku space proxy, because the proxy intercepts the TLS handshake. And okay, maybe I think I did a small mistake here. Let me go back to my EKS file. I guess I didn't enter this. Copy, paste it. Hyphen hyphen name is my cluster. Okay, now it is updated. Let's run kubectl apply hyphen f fluentbit.yaml again. If it's still failing, then we can uh, we can add the flag and you can bypass. Not a problem. Yeah, see, it is now creating because we forgot to set this context. No problem. Once after you deploy the Terraform, ideally it shows, but I ignored actually. See, apply complete, and then somewhere around here I went to the different screen, right? Because that's why it is not showing. Yeah, see here, update the cube config. I forgot to update this actually. Just copy this command and run it so that the context is going to set for your current running EKS cluster. All right. If you watch carefully here, which was created, and then created. Good. And now we have to create the Lambda function, guys. Just scroll down to the here it is. So create the Lambda function. So I'm going to name the Lambda function as AIOps log analyzer, and we need to attach two roles. One is Kinesis read-only access, and then Amazon Bedrock full access, because our Bedrock is going to invoke here. And then it's going to read the whole error file and it's going to send a Slack notification. That notification, how we're going to receive is we are going to add environmental variables here, and each and every variable has been called in our code snippet. And coming to the API model, if you see, not API model, AI model, if you see, we were taking OpenAI dot GPT. Yesterday we faced an issue with Claude due to some issues. So instead, I tried to test it with the OpenAI for now, and it's working. So that's the reason why I'm taking this OpenAI model now. So let's go back to our Lambda, create the Lambda function. Let's do it step by step. Just come back here and just say Lambda, open it in a new tab. See, don't think in a way that I'm going fast. I believe I'm going slowly only, but the problem is if someone doesn't know the basics of this Lambda function, AWS Cloud, DevOps, full knowledge, not just basic knowledge on creation of EC2 instances, VPCs, and etc. That's a very basic level knowledge. But if you know how to write modules on the existing templates, and then like writing different modules for each resources, like separate Elastic Beanstalk, separate S3. In our real-time S3 itself looks somewhere around 2000 lines. So if you know such level of understanding, then you will be able to understand this AI task, guys. But if you're not having such level of knowledge, then honestly, you will struggle. All right. So just click on additional settings, and I'm going to say custom execution role, and I'll say create new role. I want my Lambda to access two services. One is Kinesis, and the other one is Bedrock. So I will say uh, Kinesis full access, Amazon Kinesis full access, and then Bedrock full access. All right, if you see the documentation here, Amazon Kinesis read only access, but yeah, it's fine. Full access is also fine. If you wanted to restrict it, just go with the read only access itself only. And the Slack URL, just copy this, go back to your this one again, just click on create role. That's it, and save it. Scroll down and then create Lambda function. All right, good. Now just click on the configurations, increase the timeout period. Maybe you can keep 1 minute, that is sufficient. And scroll down and click on environment variables, click on edit, click on add environment variables, and then paste your Slack webhook URL, because the error, whatever you see, let's say a 10,000 lines of error is coming, but we don't waste time reading all those 10,000 lines. Instead, we need just one, two, three, four liners and say what exactly the issue is. So, what webhook URL you have to paste here, I will tell you. Just if you scroll up, we have to create one. We have to create one. Slack webhook actually. So this step we forgot, but yeah, let's do it now, not a problem. So I'll just open my console again, and I'll click on Slack API application. The link will be URL will be like this: api.slack.com/apps. All right, just say create new app, and then from scratch, and I'm going to name this as DevOps Alerts, and namespace is AIOps only. So before doing this, make sure you're creating one Slack account. Just sign up and then come back to this step. That is enough. Click on Create App. So the moment it has been created, in the left side you can see incoming webhooks. Just click on it and click on the toggle as enable on. So add new webhook, and now it's going to ask you what workspace. Just select your workspace, and the channel is DevOps alerts. Okay, we just created one. Or let's do one thing. I will just give it to all AI ops. Okay, so okay, I will just give it to all AI ops, and then allow. So this is going to allow now, successful. Just copy this webhook URL, go back to your Lambda function, and then paste it here. Just click on save. So once this is done, you have to also trigger this kinesis as well, enable the trigger. So for that, you see some triggers option here. Just click on it and just select this, click on edit, and then just activate trigger, batch size 100. Just say save it. So just in case if triggers were not showing showing here after allowing the execution role like full access, uh, IAM role. If it is not showing here, you can still say add trigger, and you can say kinesis here. All right, and just select what kinesis stream you have created. Select the stream name, and then this is optional. Activate trigger, and then click on add. Now, not it's not going to add because it's already there. So it will be duplicate for me. And then fine, now the code part, just go back to our Lambda function, just copy the snippet carefully. See, this I have been generated from uh, chat GPT itself only, or Gemini, whatever you say. Just Make sure you're also copying it and paste it in the chat and understand what exactly the line by line, what exactly it is doing. So I have generated this as per my requirement, so you can understand what exactly it is doing. Because in real time also sometimes they're gonna ask you, do you know Python or do you know some XYZ? You can tell them, see, we actually do have internal AI license tools. So if you're expecting a coding experience from me, I'm not the right person. I would rate myself as 1 out of 5. And we have an internal licensed AI tool. So to meet the developer and stakeholders requirement, we generate the code from our licensed tools, and then we will test it in the lower environment until and unless the developer requirement is meeting. And then once it is good, then we will slowly move into the upper environment like pre-live. And there, once it is also good, after developer is checking if it is meeting his requirements, then we will proceed with the CR on prod. So you can answer it this way. In interview, if someone is asking what were your coding levels, I believe it works. Actually, it's a genuine, most genuine answer. All right, good. We have created Slack. If you go back to the Slack chat here, I guess I can see all AIOps. Yeah, here it is. I can able to say this. And then webhooks have been created. Just go back to this step again. Now comes, did I paste in the Lambda? Yeah, the code was pasted successfully, and now the testing. We have to test it, guys. If you watch this step 6 carefully, we were just deploying a pod called BusyBox. Okay, so the name we are giving is error generator, but this is a BusyBox pod. We mostly use this in a test environment. Okay, so just paste it and run. So once this has been ran, you have to give two errors. Okay, see, I'm just giving errors intentionally because I cannot go back and generate some errors from the application side. So just watch here. We were just printing a database connection error. Okay, and then second error is print an out of memory error. Now if I copy this, just echo and then error, I'm just passing it. I just logged in here to my busy box. Okay, kubectl exec -it, and then I logged into this busy box pod, and I'm just pasting it here. The error. Watch carefully. Now this busy box has been generated an error. Okay, that error is what? Some DB connection issues. Usually in Kubernetes, you know what will happen? We need to go to the rancher, like we were holding it on Lancer. We have to go to the Rancher. Out of 11 clusters, we have to identify from which cluster the issue is, and then log into the cluster, select the pod, click on kubectl logs, click on the kubectl describe pods. We need to do all those stuff. By following these strategies, now what will happen? It's not going to show you all the logs like 100, 150, 200 lines of logs. Instead, it's going to filter what exactly the issue is. All right, now we know here because we are intentionally passing. In real time, you see a different issue, but you have to, if you want to understand what exactly the issue is, you have to go through all the logs, right? Now, watch carefully. I'll just go back to my console again and I'll refresh here. Look, I got an alert in my Slack. Just see, it is giving the whole steps here. So just scroll down, and then you are going to see the issue here. See, observe symptoms, error, connection refused, PostgreSQL DB user this, expect exceptions, fatal password authentication failed for the user admin. Okay, this is actually again a big message we are getting on Slack. We can still, I'll give you a small assessment here. See, just use any anti gravity tool, and then open an agent. I'll just open my agent, and I'll just say the alert to the Slack is quite heavy. Please reduce it to 4 or 5 liner by saying what exactly the issue is. Also, please modify my lambda logic accordingly. Okay. Please don't use CLI instead. So first and foremost, what I will do is for your evidence, I'll just delete these messages. Okay. Let's pass one more error and just delete this as well. This is looking heavy for me. I don't want this big message. I want some simple, straightforward, sweet message. Sweet alert, I would say. I'll just come back here. Okay. It is changing some line here. It is importing Moto 3. Okay. I'll just accept. Regular expression cleanup. Okay. To script out the model internal trace completely before sending the text to Slack, stripped out formatting replaced. Okay. Understand. It has been installed a package called RE, which is specifically used to format the whole lines. All right, let's pass one more error, guys. Just test it one more time. Now let's pass the second one. Okay, this is part of out of memory. I'm just passing one more error. So it says error Java space. Just go back here and just refresh. So now we got one more error, one more alert. Now this is something good for me. Okay. So error out of memory, and then the application pod throws a Java heap space out of memory while executing data processor load. Yeah, see, this looks quite okay for me. Root cause analysis also it is giving container memory, JVM heap, memory leak, and then proposed fix YAML resource request 2 GB, and then CPU limits 500 MB, and then 4 GB, and then one CPU. Quite. This is good, right? If you still wanted to tune this and wanted to look only one, two, three, four liners, like simple and sweet, then you can still go back to your agent and then ask it to, like, develop more precise way. So that's all for today's session, everyone. I hope you have understand. See, uh, you can go ahead and apply this in your prod environments, not a problem at all, because this is not impacting anything. This is still giving you and saving your additional time, right? But before suggesting it to prod or to the stakeholders, make sure you're testing in the lower environment, understand the pricings, because here we don't need any server, guys. If you watch here carefully, it's a event driven architecture. All right. So you don't need anything here, any servers running in the background here, but just understand the pricing, costing, everything. And if it's okay, then suggest it to your stakeholders and take approvals from everyone, and you can start implementing on the lower environment, and then pre-live, and then prod environment with the CR. All right. So that's all for today. Now let's clean up everything. Now the cleanup activity. I'll just exit from the BusyBox pod, and I will say Terraform destroy hyphen hyphen auto hyphen April. So this is going to destroy my whole EKS cluster, and then okay, it's still throwing the messages. It's okay. I'll just remove this flag. I'll just click on function and I'll click on delete. So if you're doing this practicals, I would suggest you to do it with the help of Terraform. Okay. Terraform is Terraform will be very easy if you know the console steps. In console, let's say if you wanted to create a VPC peering, all right, that is the console step where you're going to enable the source and target routes, and then vice versa. You're going to approve the peering connections and all. If you know those steps, Terraform is easy. Likewise, you have understand the manual steps now, right, which I've shown. When you're doing the practice, do it manually once, and then second time when you're doing, take ChatGPT help and try to deploy the same with the help of automation, which is Terraform. Delete log stream, and in the background we have created one service account, right? So you have to go to the cloud formation templates, and in the cloud formation template you're going to see one stack. So delete that stack, deactivation, save, and then I'm going to select delete stack, copy my stack name, paste it, delete stack. Great. Creation complete. I'm deleting, right? Deleted in progress. Okay. So in the background, just watch. Yeah, this is also going to delete. That's all. I think we have not created anything from the console. I hope you understand the session, everyone. If you're doing the practicals, make sure you're posting it on the YouTube. Sorry, make sure you're posting it on the LinkedIn, and try to write the Medium articles or try to do your own documentation. That would help during the real time tasks or something. See you in the tomorrow session, everyone, and have a nice day. Bye. Take care. Hello everyone, welcome back. My name is Saikiran. In today's session, we are going to do one more important activity on SageMaker. This is actually part of machine learning operations, everyone. So please do it carefully. And also, once your task has been done, make sure that you turn off all the resources, else you will see a lot of costs. All right. In my previous organization, we do have a team called Neon Team, guys. So this team specifically works for a clone of a streaming platform, I would say. All right, I'm not gonna name the platform, but they are specifically gonna work on a clone of this streaming platform itself only. We do have machine learning developers there, not full stack developers, backend or front end or someone. We do have a machine learning developers here, so their job is to train the models. The moment if I mention models, meaning here the SageMaker models they are going to generate. So for example, there is a payment application for that streaming platform. If a customer swipes in with an ATM card or debit or credit card, or if a customer gives any details online, so this model is going to identify whether this transaction is fraud or whether this transaction is real. All right. So how this model is going to identify? Again, this model is going to train on some severity numbers like 1, 2, 3, 4. Likewise, we do have severity numbers till 10. So I will tell you what exactly were these numbers. For example, um, let's say there is something called velocity. All right, meanings velocity meaning how much amount the person is withdrawing or how much amount the person is debiting, right? And we have something called country. First, this model is going to identify from which country this money has been, debited or withdrawn. And also, we do have one more classification here, that is mobile device. So out of these three classification, let's say if a person is doing a transaction from India through this payment gateway or payment application, let's say he did somewhere around 10,000 rupees transaction. All right. Immediately the very next day, this transaction has been changed from India to, let's say, Denmark. All right. And the transaction is somewhere around more than 1 lakh rupees. So in such case, this model is going to identify and rate the numberings and tells the API that there is something wrong has been happened. All right. See, let's not talk more about that application, but because I'm not a security guy or I'm not a PCI or someone who works on the payment application. But to be honest, this is the application flow. Their requirement is this: they are going to train those models. But the problem here is we as a DevOps engineers or we as a cloud engineers or whoever we are, see, we six members going to sit in a cloud place, and whenever they train this model, they are going to tell us that, hey, the model has been uploaded. Either they are going to upload it locally or they are going to upload on the S3, right? The problem here is we do not know what kind of Python version this developer has been used, machine learning developer, or we do not know what kind of dependencies he has taken. Let's say if they are giving any repo access, right? If we get any repo access, then it will be very easy for us to identify what versions they have taken by choosing the Docker file or pom.xml file or whatever the dependencies we're using. But unfortunately, we do not know what kind of Python versions, dependency versions, whatever they were using, we never know. And also, every time, like whenever they identifies a risk factor score here, or every month or every 2 weeks once, they are going to upgrade this model as well. Upgrade meaning in the background they are going to train that model. Again, finally they are going to upload this model to the S3 bucket, and they will keep us posted that here is the model. That model looks quite heavy actually. It will be the .pkl, that ML model. So it looks heavy, and it will be becoming very tough for us because we need to again pull this image, pull this file to our Docker image, and we have to containerize it, and we need to upload this into our Elastic Container Registry, and we need to tag it either if it is v1, v2, or v3. See, previously what we used to do is we used to follow some manual interventions, guys. So, and then later we came up with some automation. So, in today's session, we are going to do the exact machine learning automation itself only. But regards to this model, we are just going to create the basic model, all right. But we are going to concentrate more on how a machine learning model, trained model, gonna upload to S3, and how we're gonna create a pipeline, and how we're gonna create a Docker image. All those things we are going to discuss today, right? So we are going to use GitLab today for today's session. All right. So GitLab runner for we have something called SageMaker.py job. So it tells, say, the moment you push the code to the GitLab, automatically it tells how you have to train the model. That code and everything was there under like SageMaker job.py. We do have the MD file also. So once you see that, you will understand. So once the training has been completed, then the S3 is going to involve here, because whatever training has been done on the stage one, that file is going to upload to the S3. So next we have GitLab Workspace. All right. So this GitLab Workspace is going to fetch that model from this S3, and it's going to extract it. All right. And it's going to store in some XYZ location. I will tell you what exact location it is. Now then our Docker is going to involve here, and our Docker is going to fetch this file dot pkl file, which is the trained model, and we are going to create one image, Docker image. So once the Docker image has been created, then we are going to upload this image to Elastic Container Registry. On top of it, we are also already going to deploy two resources here. One is EKS cluster, and the other one is Terraform. I'm sorry, not Terraform, GitLab. Using Terraform itself only. Before coming to the session, I already deployed. However, I'm going to give you the code part, don't worry. So it took somewhere around 15 minutes. It's a waste of time in the session, so I deployed it already. EKS and then GitLab, both were going to be deployed from the Terraform itself only. See, GitLab, and once the training has been started, the training model is going to upload an S3, and GitLab Workspace is going to extract that file from the S3, and it's going to upload in its local area called model, and our Docker is going to involve and fetch the file from this model, and then creates a Docker image, and this Docker image is going to update to our ECR. The moment a tag has been updated here, immediately we have a very important GitOps, which is Argo CD. So this Argo CD is going to monitor and deploy the changes onto our EKS cluster, guys. So this is what we are going to achieve today. So let's go and do the practicals, everyone. So here is our console, everybody. Before coming to the session, I created one GitLab server, and I created one EKS cluster, and that does have two node groups. And also, if you see this IDE, we also set the context as well, and these are my nodes. All right. If you go to the documentation here, again, I would request everybody to read why we are doing this, what was the architecture, and also the why factor in each and every step, right? See, this step has been completed already, and this is the infra.tf file we have used. And so this is the main file we have that deploys both GitLab and the EKS cluster in Asia Pacific, which means Mumbai region, not in the North Virginia region. So before doing this activity, I would request everybody to raise some resource quotas. So if you go to the resource quota, or if I say service quotas, so you can come here and then click on AWS services and just say SageMaker And here you see one MLOps M5 large instance. All right. So make sure that your, I'll mention here, ML dot M5. Yeah. See, these instances, you should have at least one, guys, because we are going to use this instance, right? Of course, I'm going to use some spot instance only. I don't need any on-demand instance. But before coming to the session, make sure that you're using, that you are raising a request for the AWS to give at least one ML node ML M5 2x large instance for our testing purpose. All right. Or else your pipeline is going to fail. Or if you don't want to do it, then you can take any T3 or T2 instance and you can do it, but you will see some latencies and failures. Got it? So I'll just close this. And if we go back to the document again, let's follow the steps here. So the context has been set already. And now I'm going to log into the GitLab server. So my GitLab IP is this. It's running on this public IP. And I'm going to enter the root credentials directly because this is testing, right? So I don't mind. It's fine. So I'll just connect and we have one small command here to grab the credentials. This is the command. Just copy this and just hit enter. So this is my password. I'll just copy and just paste it. Sign in. Now, first and foremost, let's create two repositories. One is for the source code and the other one is for the manifest file. So I'm going to mention here, I forgot to mention. So I will just say the document part 0. I'll say create repos, one for source code, one for manifest. And just hit save. Let's go back here and then just skip everything and skip this one as well. See, if you wanted to log in as an admin, you can still log in, but you have to come back here and you have to acknowledge, or else by default as an admin user you cannot log in. So just create a new project. We are going to take two manifest files. One is this and the other one is for the source code. Two repos, sorry, one is for the source repo, other one is for the manifest repo. Let's refresh it again. Create blank project. I will say MLOps runner. Okay. And then for the second one, I'll keep MLOps manifest. Okay. So I'll just remove this source. And then I will select the project URL for root and then click on create project. So this is one repo. Now we are going to create one more repo. So I'll just go back here again, click on projects, new project, create blank project, and I'll say MLOps manifests. And then scroll down, click on root, create project. That's it. Leave it for now. We do not have any work with these projects. So let's go back to the documentation. First and foremost, SageMaker and then ECR preparation. ECR preparation. We are going to create IAM roles and S3 buckets in this step one. See, if you read it here, SageMaker needs an execution role to read the training data from S3, and your GitLab CI pipeline needs a user to trigger the jobs. Right. So first and foremost, we are going to create an S3 bucket. Why we are creating? Because your SageMaker is going to fetch some information from the S3, and also once after the training module has been built by the SageMaker, it is going to store that PKL model as a zip file into our S3 bucket itself only. So for that reasons, we need a S3 bucket here. And again, Elastic Container Registry is for Docker build image. Finally, we are going to use some Docker and we are going to build an image. Once after the image has been updated on the S3, we have something called GitLab Workspace. We are going to create one IAM GitLab user account as well. So that workspace user is going to fetch the pkl file from this S3 and it's going to unzip, and whatever file is going to come after the unzip, that pkl file is the very important file that we are going to use in the Docker, and we will create an image. And finally, that image will be moved to a Elastic Container Registry. For that reasons, we were creating the registry here. And finally, IAM, as you know, that vice versa, they should have some handshake method. Directly, they cannot go and access whatever we have given. So I'm just creating full access, adding the policies called S3 full access, and then also SageMaker execution role as well. All right. So let's start with the bucket. So I'm going to create one bucket called MLOps training data. Just come back here to your AWS and just say S3. So make sure you're in the Mumbai region only. Create bucket and then scroll down and click on create bucket. Done. Step one is done. And then Elastic Container Registry, MLOps fraud model. Just come back here and just say Elastic Container Registry. And so I will just delete this. I forgot to delete the Medibot one, which we did previously. Create repository, and I will say this as MLOps fraud model. All right. Just don't do any changes. Scroll down and then hit create. Fine. ECR has also been created. Now what is next? IAM and then create role. And this role is for service called SageMaker, and we need to attach Amazon S3 full access, and then anything else not required. Just Amazon S3 full access is required, and then SageMaker execution role. SageMaker execution role will be there already by default because you're selecting the SageMaker service, right? So I will show you practically. Just open IAM and just click on IAM roles and then create role and then service. Make sure you're selecting the SageMaker here and hit enter. Next. See, you cannot be able to add any other policies here. So for now, just click on next and then create SageMaker role. In real time also, we are adding only one policy here. In real time also, guys, um, we are going to follow the same strategies itself only, but there you are going to use some private standards. There will be no public subnets or any resource that is facing to public. All right. So now we have successfully created one role called SageMaker role. Just go back here, add permissions, attach policies. I will say as full access and then add permissions. Good. Now we do have S3 full access and then Amazon says Michael full access. Fine. Now let's come back to the next step here. Create an IAM user called GitLab CI user. See, this user will be having SageMaker full access, EC2 Elastic Container Registry full access, and then S3 full access. Why? Because this CI user is going to fetch the information from the S3, whatever this SageMaker has been uploaded to the S3. That's the final model, and that final model is going to pull to your Docker image, and once the Docker image has been built, and it's this user is going to upload it to the Elastic Container Registry. So for that reasons we need these three policies. Just copy this, go back and then click on IAM users and then say create user. This is my IAM username. Next, attach policies. Let's say S3 full access, and then I'll also give SageMaker full access. In real time, instead of full access, what we'll do is we will create some custom policies. Okay, you should not give full access in real time because it's a compliance issue. If you are having security or PCI audits, so at some particular point of time, they will come back with the question why there was a full access or administrator access, some stuff like that. So you have to create some custom policies there. Amazon SageMaker container, ECR. Elastic Container Registry. I think power user full access. I think let's see. power user, elastic container registry, public full access, public power user, public read only. See power. Let's copy this and see if this policy is there or not. I couldn't able to. Yeah, it is there. Just select this and click on next and then click on create user. Later we are going to create access keys and secret keys, and that will be used in our GitLab variables. That is a secondary thing. So we'll do that later, no problem. So this whole part is completed. Now step 1.5, install and configure GitLab runners. Yes, because we are creating a self-hosted GitLab runners. We were not purchasing any managed GitLab runners from the GitLab, right? So for that, we need to configure it, or else your pipeline is not going to trigger. All right. So this GitLab CI/CD pipeline needs a runner with Docker executor and privileged permissions to build the Docker image and deploy. So now let's log into our GitLab EC2 instance and let's install Docker. So I will just paste the command here. You can also enter check URL and then https://get.docker.com space pipeline space and then bash. So that is going to install the Docker as well. So you can install it in a multiple ways. So once my Docker has been completed, now I need to add the GitLab runner repository. Just copy this command. Just say Docker version. Let's see if it is installed or not. Yes, it's installed. And then paste this. Install GitLab runners. Yeah, just copy this. Enter. Go to the document again. Add GitLab runner user to the Docker group. Okay. So just select this command. See, read the command sudo user mod hyphen a hyphen g means all to the group user called user to Docker and a username called GitLab runner, right? So if you come back here, it's still downloading. Let it be. All right, this has been completed. Now I will just user mod run command, and then this is the command we just created. Now create and register the runner in GitLab UI. See, why we are doing all these things is in real time we can automate everything. Whatever steps you're watching on the screen, in real time we are going to automate it with the tool called Terraform. But I cannot automate everything here because I have to show something to you, right, manually. So that, however, we created the cluster and then the GitLab GitLab repo with Terraform itself only. So all these steps need to show manually so that you can do automation later. And now create and register the runners in GitLab. You go to your project settings, CI/CD, expand runners. Just come back to the GitLab project and My project is this MLOps runner, and then settings, CI/CD, and then click on runners, and then say create project runners. So just give tags. I'll say MLOps runner, and then here you don't need to give anything. It's optional. And max timeout seconds, just give 600 seconds. You can see the document here, new project, example MLOps runner, create runner, and copy the generated authentication token. Okay, fine. So just say create runner. Now see, this is the authentication token. If you can watch here, just copy this and go back to your project runners, description MLOps runner, sudo GitLab runner registry. Just copy this first and go back to your session and just run this. So it's going to ask your GitLab URL. My GitLab URL is this IP. Copy and then just say colon double slash. I'll just paste it again. That's it. Just enter. So registration token, the token is here. Just copy this and then paste it here. So enter a name for the runner. This is stored in a local. Okay. Now just come back here. You'll be having one runner name. So make sure you're giving the runner name as is. Okay. Just to avoid the confusions. And then Docker. Enter enter the default Docker image. For example, you have to enter Ubuntu latest here. See if you see the document I have mentioned already. However, executor is Docker. Default Docker image is Ubuntu image. I mean Ubuntu latest. So just hit enter again. It says with the authentication was saved in config.yaml file. Now if you go back to the document again, so it says enable the privilege mode. How you can enable the privilege mode? Just copy this command config.toml file and you have to change the privileges settings into false to true. Under runners you see something called privileged. Alright. So just change this to true. That's it. Control X Y enter. You see the document, the same thing I mentioned. Privilege equals to true. Save and then we need to restart the GitLab. Just paste it. Enter. So let's check the status. Sometimes if anything goes wrong, it fails usually. So now it says active and running, which means our GitLab is up and running now. Okay. And configure runner to the untagged jobs. Go to the GitLab settings, CI/CD runners. Click the pencil icon on the edit your registered runner. Check the run untagged jobs. Okay. So this is our GitLab repository. Um, we were already at the runner registration itself only. So I'll just say CI/CD settings. Now I'll say runners. Just edit and run untagged jobs. This is the one that it was talking about. Save it. Good. Now model code and GitLab CI repo, and this needs to be stored uh, in your MLOps runner itself only. All right. So first and foremost, what I will do is I'll just come back to the MLOps runner repository, and I will just copy this, and I will take a new screen here, and I'll say um, git clone, and then I'll paste it. So username is root, and then the password is my token only. Maybe I think copy So this is my password. All right, we have cloned successfully. Now this is my repository, MLOps runners. So it does have .gitlab-ci.yaml file. Um, no, I think this is not the repository. This is the repository, MLOps runner. This is the old one. I will delete to avoid the confusion. Standalone. This is not mine. GitLab. All right. Okay. Now it's good. So this is my repository, MLOps runner. I'm inside this. Only readme file was there. Now, if you go back to the document here, to create two repos, one for source code. No, not this one. Yeah, here it is. Model code and GitLab CI repo on MLOps runner. So first and foremost, I will just say app.py, and we need one Flask API application where it needs to serve the prediction, guys. In the introduction, I told you, right? It's going to predict the swipe history, how much a fake it is and how much real it is based on the numbers. So for that, I need one small Python app, and I'm taking this. Um, app.py, and inside this app.py we have a small code here. If you watch carefully, scroll down, the model is packed into, yeah, till here. You have to copy and paste carefully. Copy, and then paste it here, save it. All right, and if you go back to the documentation again, we have one more file called requirements.txt. This is the dependency file and which contains these two. Okay, just a text file, nothing else. So again, I'll come back to my MLOps runner and I'll create a new file called requirements.txt, and inside this I'm going to paste this too. Copy, paste it. Now document again. Now we have a Docker file. Let's copy this MLOps runner. Just say Docker file, and then come back here, and then just make sure you're copying your Docker file carefully. This is the important step. Save it, and again back to the document. So now we are going to create a SageMaker training script. So just read the Y factor here. This GitLab CI pipeline triggers SageMaker. Yes, correct. And then to train the model. So wait, so what exactly it is going to train? The training whole stuff will be sitting inside uh, the whole training stuff will be sitting inside here. Run underscore SageMaker underscore job.py. This is the training script. So using this, SageMaker is going to train the script the moment pipeline has been pushed, and the artifacts will be uploaded to our S3, and our GitLab user is going to fetch that unzip zip files, and it's going to unzip and store into a Docker image. All right, that's the flow actually. Now create SageMaker training script, the GitLab. Okay, now let's say create a directory called scripts. So I'm going to stand here on the MLOps runner. Let's create a new folder called scripts. And inside that folder, I'm going to create one file called run SageMaker job.py. Paste it. And inside this, make sure you're pasting your whole code. Import OS time. Make sure you're going through the code, whatever I've mentioned here. See, I have also generated this from the Google Flash itself only. From nowhere else I've written because I'm really not that good in coding. But let's try to understand what exactly this is doing by pasting in some files. I mean, some ChatGPT or Claude or some other AI tools. If I go back here now, till here it is done. Step 3, write the GitLab CI pipeline, because we know why we need a GitLab CI pipeline. So the CI pipeline is orchestrated. It uses Docker Dyne to build images and the AWS CLI to authenticate. So for that, we have some variables here like access key, secret key, region, SageMaker, role AR, and S3 bucket, and then GitOps token and all. So now let's do everything step by step. All right. So first and foremost, um, this part is done. I still didn't push yet. Nothing was there here. So I will push this later. But for now, let's finish up with this variable part. The pipeline ensures that you have added the following environment variables to your GitLab project settings. Now go to the settings, CI/CD, and then variables. Come back to the GitLab settings, CI/CD, and then the variables. Let's start adding the variables here. Add variable, protected variable itself only. Key, first and foremost. What was the key? The key name is AWS Access Key ID. Copy this and then paste it. What was my access key ID? If you go back to your IAM user security credentials, create access key, others next, create access key, copy the access key, and then paste it carefully. Add variable. Add one more variable, which is a secret key. Why we are using? We know already. We created one the GitLab user, and that user is going to fetch the information from the S3. The information will be stored in the zip file. So I'll just copy the secret file as well. Guys, once the session has been completed, make sure that you're deleting the all access keys and secret key IDs. So default region, my default region is AP South 1, which is Mumbai. Copy the region, just say key, and then my region is AP South 1. Copy, and then paste it. Add a variable. What's next? SageMaker role ARN. Okay, just copy this. SageMaker. Where is my SageMaker role? It should be here itself only. I am roles. Just search for SageMaker role ARN, and then the ARN here, and then paste it carefully. Add variable. And what is next? S3 bucket. Okay, copy and the paste. MLOps 2026. Good. Finally, we'll be having GitOps token, because make sure you're collecting the token of a repository too, which is what? Which is your manifest file repository. Why we are doing it? Because when the image got updated, later we are going to use Argo CD here. That Argo CD should deploy the changes onto our EKS cluster. Okay. For that reasons, we need a manifest file report token, not your source file, source report token. So I will just say GitOps here for the key, and for the token, I will just open in a new tab, or else I'll just duplicate this and then just go back to the projects and manifests, MLOps manifest. So settings, access tokens, add new token, token name GitLab runner says maker. I will say maintainer. So I need these two, write and read access. Actually, write is sufficient, but let's take these two and create project access token. Just copy this, come back to the GitLab CI, and make sure you paste this here. Add value. Now GitOps token was done, and then says maker instance type. This is optional, but you can ignore. If you wanted to use T3 or T2 or some other different instances instead of these instances only, yeah, then you can use it. No problem at all. All right. Now let's create .gitlab.ci YAML file. So I will just come back to the MLOps runner. I will say enter. and here you have to paste your code. So these are my stages, and paste it. GitLab, I'm sorry, I'll close this. Save it. Done. So go back to the document again. Part 3, GitOps manifest. So that's what we were discussing in repo MLOps manifests. You need to create one file called deployment.yaml file. All right. So this will be replaced. Image placeholder will be replaced, but you have to change your MLOps uh, Elastic Container Registry name here on the customization. So just go back to the Elastic Container Registry and copy the ARN, open it. So the ARN will looks like this, the repository URI, and then just change this, save it. So for now, just copy the GitLab.yaml itself only, and go back to the, I'll duplicate this again, and now I'll open manifest repo. I'll just say new file. This should be deployment.yaml, and then paste it. Commit changes, commit. So now if you watch the deployment file here carefully, we were deploying uh, something called model fraud-model API. Number of replica sets were 3 and the labels were fraud model, and the app is this. All right, and the name API image placeholder. This will be replaced by customize once after you run kubectl apply. So now we are going to do that step again. Just come back here. See, this is the one. So I'll just copy this. When pipeline runs, this file also runs. When this runs, automatically this is going to replace this. All right, you don't need to worry about it. MLOps manifests. Again, new file, and here you can say customization.yaml, and then simply say commit changes. Scroll down. Now we have to deploy the Argo CD. So we are going to deploy Argo CD in a namespace called Argo CD, guys. Right? Just copy this. Let's center, and then namespace created, and along with this Argo CD should also be deployed. Create the Argo CD application link. This tells Argo CD to watch our MLOps manifests repo and sync it to the ML workloads namespace in the EKS. Okay, all right. This has been deployed successfully, and now if you watch carefully here, create the Argo CD application link. Okay, this is the application the manifest file. See why we are doing this. This means this manifest, whatever is there, is going to tell Argo CD to watch our MLOps manifest. See here we are calling it. Okay, so it is going to watch this MLOps manifest repo, and it's going to sync it with the MLOps workloads namespace in the EKS. Got it? So for that reasons, let's copy this, and then I would say nano Argo CD hyphen app dot YAML, and then paste it, Control X Y, use schedule, apply hyphen F, enter. Ideally, I shouldn't create this inside this MLOps runners. Should have created outside of the MLOps runners. So if I enter ls-al, Argo CD app. Okay, I will do one thing. Move Argo CD YAML to // outside. So now that was not there, right? Okay, fine. Git docker app.py requirement.txt and then scripts. Fine. Now what is next? This has been deployed, right? Just scroll up and see. Yeah, this has been created. Kubectl get pods. Any specific namespace we have created? Namespace called ML work copy. Paste it. Enter. Ideally, it should be there. Kubectl get pods hyphen ML workloads. What was the next step here? Finally, kubectl get ns. Yeah, this is expected actually when Argo CD deployment starts and when it's in the sync, automatically you can see this namespace called ML workload. So that is expected. It is okay. But we have did a small minor mistake here. Repo URL is HTTP. It's not HTTPS actually. It should be HTTP only. Okay. HTTP colon root and then this. Okay. Let's see. Just say copy and then I'll just come back one folder. Nano. Um, that name is Argo CD YAML. And yeah, this is the one HTTP 13. That's my IP root and then MLOps. Good. Control X. Sorry. I'm sorry. Just say no. kubectl hyphen F. Just redeploy this again. Now it's going to point out to our exact GitLab repository. This manifest repository. MLOps hyphen manifests. Let's come back here and check. MLOps hyphen manifests. Yeah, perfect. Now go back to the documentation again. So I'll close this. This is my document. Now let's do the final testing. Yes, we are going to trigger the pipeline. However, we didn't push the code to our source repository. The moment we pushed, automatically it should trigger the pipeline. So let's see that. I'll just close this. And if I go back here, cd MLOps runner, git status, and I can see GitLab file, Docker file, requirements and everything. I'll just say git add dot and then git commit hyphen m. I'll just say add all files testing git push enter. So this has been pushed immediately. If you come back to your MLOps under here, you should see the pipeline is running. And also you can go back to your S3 bucket and just refresh here. It should create one file or directory called model, and it should start pushing. See, preparing Docker executor using executor with image Python 3.1, 3.11, sorry. It says pipeline was failed. If you see the error here, uploading training packages to S3 masked source star.z says Mercator MLOps fraud. Let's see what was the failure here. Line number 1094 make. Okay, here it says when calling the create training job operation, the account level service limit for ml.mfile large for training job usage is 0 instance. I'm facing this issue for a very, very long time because it's been already 2, 3 days since the same issue I'm getting. Even I do have this. If I just copy this, if I go to the service quotas, I requested and they approved as well. If I say sales maker and paste this here, this was not reflected, I think, yet. My bad. M file large for training job usage. All right, I'll do one thing. I will try to involve any other least machine CPUs and then hard disks. Let's see if that works. I'll just say Control Shift L. Um, so the issue is here. That works in let's see if our agent helps because I've been facing this issue for almost 2, 3 days. It has been taking so much of time only because of the MLOps model. That model is not available in North Virginia, so I shifted to Asia Pacific. They have confirmed that I do already have a spot instance model. Oh my god, let's enable this. Well, let's do one thing. Let's use Flash. So if this is not working, I'm not going to take another day or 2 day time to complete this task. We almost completed setting up the whole stuff, guys. Whole stuff, everything. You see, so whatever you are watching here is just a testing part, the bottom one. Okay. So I would request you guys to do it. These are all these are all deletion part, cleanup activities. And here, if you see, these are all testing part. What you can do is you can just pass some fraud. Let's see, I will run the Python command to query or AWS resource developer says we can training instance types in AP Southwood region. This will show us which instance types are non-zero. Okay, just go ahead. So if it is not working, then what you will do is initially when doing this activity, make sure you are taking this resources available. Okay, you are requesting for the resource available. Just copy this and then go to the resource quota and paste it here under sales maker service. Make sure this should be at least one or two. Okay, here see, if you see, everything was zero. um if I go to the North Virginia here, Open link in new tab. If I paste the same thing here, ML M5 for training job usage. See, I requested actually. I don't know why it is not showing here. If I go to the support ticket as well, or else you can see the quota history request here. See, I requested it, case open, and maybe someone is working on the North Virginia, but that is the reason why I didn't do this activity on the North Virginia. I'm doing it on Mumbai. See, so they were asking for some reasons here. I will respond later. But for you guys, almost the task has been completed, so I don't want to take additional time here. So please first try to bring up the M5 instance. Take request from the AWS. Once you get approval only, then do this task, or else just ignore this task and proceed with the other activities. Okay, so I will just wait for some more time. That is just trying to fetch something. I would tell this task is not an incomplete task. This task is completed task only. But the only thing what you have to do is request for M5 instance and then run this testing commands. That's enough. That's more than enough. It says it's still working. All right. I will stop the recording for here. And I'm going to delete the resources. It's already 4 p.m. in the afternoon. I've been sitting with this task for almost 10 a.m. in the morning. Still, it has been edited. What has edited? Let's not compare. Let's see. Says maker dot job. Let's see what were the changes. Try if local training request says make type is local and the requirements.txt it is same. GitLab CI. Okay. Okay. Yeah. Fine. Every section push the changes to trigger the pipeline. Git add dot commit. Okay, we'll do one thing. Let's run git status. Let's see if it works. If it fails again, then yeah, let's stop it here and let's go to the jobs running. This issue is only because the resource limits and quotas. M5 large instance is quite expensive. It is running for me. I mean, if you ran that for almost 1 hour or 2 hours, you see lot of bills. So keeping such things in mind, AWS is not giving access for M5 large instance. However, they should. Oh, it is passed. Very nice. Excellent. SageMaker training could not be completed. An error occurred. Resource. It's failed actually. See, please use AWS service quotas to falling back to the training model locally on the CI runner. If you go back to the SageMaker and see, is there anything? Not this one. Sorry, this one. Dashboard. I think no, nothing was created. See, everything was zero here. Zero, zero, zero. All right, guys. I'll destroy everything. Make sure you run Terraform destroy, and then also make sure you delete the resources whatever you created manually. Please try to fix the resource quota issue first. Don't face an issue like me, and then you can proceed with next. Thank you so much, and have a nice day. We'll see you in the tomorrow session. Hello everyone, welcome back again. In today's session, we are going to do one more activity on threat detection. All right. But before jumping onto the task, what exactly we want to do and understanding the empty file and all those stuff, I'll explain you the flow because see, whatever we are doing today is part of either PCA task or this is part of security operations, which is not our cup of tea, but building this is our DevOps engineer or cloud engineer part, right? So first and foremost, we are going to enable guard duty, right? See, guard duty is something where it's going to identify if any malicious activity is happening or if any abnormal activity is happening across the entire AWS account. Whatever you see on the AWS services, so on the whole AWS services, this guard duty findings gonna enable. So this is a managed service. We are not going to create anything. We just gonna go to the guard duty and we just click on enable. That's all we do. Apart from that we don't do anything. So the moment we enable guard duty, so guard duty is going to find some alerts, and again those alerts will be rated from 1 to 10, like out of 1 to 10. From 1 to 4.5, these were rated as medium, and these were rated as low. Apart from 4.5 to 9.9, these were marked as severity level high, right? So we don't want to monitor less than 4 or 4.5. We are going to monitor only 4.5 to 9.9 because all these were critical alerts, you can say. Not high, you can say it as critical alerts, right? So first and foremost, again, we are going to enable guard duty the moment it start identifying the findings. Then on the other hand, we are going to enable the event patterns, or you can say this as event bridge. In event bridge, we do have multiple things, event rules, event patterns, and others. But here we are going to enable the event pattern. The moment you enable event pattern, meaning you should give one source and then you should give one target. All right, meaning source here, guard duty. And what was the target here? Our target is lambda function, guys. Right? See, why I'm mentioning the lambda function here? Here, lambda is going to do two things. First and foremost, it's going to uh, actually the findings whatever you see it will be in the JSON language. As a human it will be tough for us to read this JSON language, or if a developer jumps in and watches, it will be very tough for us to read it. So we are going to import some libraries like regex or any other libraries that rephrases the entire JSON and showing it in a human readable language. And the other thing what we're going to do here is we are going to involve the bedrock model, right? Underlying model is for Bedrock Nova. Nova is cheap and best Amazon by default model, which doesn't require any approvals from anyone. But if you're going for Claude and GPT, then yeah, Gemini, you should have some approvals, right? So immediately the source, which is guard duty, enables some findings. This is going to invoke our lambda function. Our lambda function is going to invoke this bedrock model, and this bedrock model is going to separate all these logs in a human readable way, and finally it's going to send a Slack notification on chat. So this is what we are going to achieve today. So why am I doing this is, again, this is not cloud or DevOps activity. At some particular point of time, your PCA team or your security operations team going to come back and they're going to ask us that we need this. We have some requirement. So what will happen next time? If any alert comes of a PCA remediations or security remediations or any vulnerabilities or CSV remediations, then everything is going to notify onto the Slack itself only. And then PCI team or security team is going to come back and they're going to ask, hey, this is the issue. We have occurred vulnerability or some issue. Can you please check? They're going to ask to the cloud team. Then we are going to jump in and create a Jira ticket and we are going to remediate that issues. Right. So this is quite a little task today, but it is very, very important. Again, you can involve this in a dev environment first for testing, and then you can involve this in pre-live environment. And then once you get approval from your stakeholders and then your developers or product or whoever it is, architecture, then you can also create a CR and apply this on the prod itself. All right. So let's go and do the practicals, everyone. So here is our document everyone, and this is our console. So first and foremost, let's understand the architecture here. So we are going to create AWS GuardDuty. First, we're not going to create GuardDuty is a managed service. We're just gonna enable it, and then the moment you enable it, it start capturing your whole AWS environment. All right, and then we are going to create pattern-based event bridge. So the meaning pattern-based means you do have two things. One is source and the destination. Source will be your AWS guard duty. The moment your source identifies any alert that risks more than 4 and up to 9.9, highest is the 10 actually, then immediately your guard duty is going to enable and it's going to invoke the Lambda function because that is the source and target patterns. And in our Lambda, we are going to have a logic where it's going to send a raw JSON to the Bedrock, and this is the AI model we are going to use. And this is where we are going to pass our webhooks, not webhooks. Webhooks will be already created on the on the Slack side. So here under environment variables, we are going to give our webhook URL. So it's going to send a notification to the Slack chat channel. So here it is. All right. So let's start implementing. So first and foremost, we are going to enable the guard duty. So if you see the Y factor here, we use AWS managed machine learning to detect compromised credentials, crypto mining, EC2s, and malicious crypto traffics. See, all these things will be provided by your guard duty itself only, ready-made, and you don't need to do anything else. Right? Just go back to the console and then just type guard duty and open guard duty. Just select enable all guard duty features and click on get started. That's it. Enable guard duty. Don't do anything. It will take some time, and after some time, it's going to give some alerts here, right? And if you go to the documentation again, so step two, create the event bridge rule. So as I said, we have two different types of event bridge. One is rule based and then pattern based. So we are going to follow the pattern based event bridge here. So I'm going to copy this. This is the name actually. So I'll just come back to the AWS account and I will say event bridge, Amazon event bridge. And see, these are all the different types of event bridge we do have. So we are going to select event bridge rule with pattern based. So click on create rule and it is asking source and then the target. So source is AWS service only. And what was the service? That duty. So just drag and drop here. And then target. What was your target service? My target service is Lambda. We still have not created the Lambda function, but we will create. Don't worry. So just scroll down and so let's go back to the document and just copy this small JSON filter, guys. We need this filter because we were trying to capture only severity level more than 5. I mean, from more than 4 to 9.9. We don't need less than 4. Those were medium and then the high alerts only, which is okay to ignore for now. Later we can fix that. So I will just come back to the filter here and just paste the JSON file here, right? So you're going to get one error. This is nothing but it is just asking us, you have created a guard duty, like you have dragged and dropped the guard duty event here as a source, and again you are giving the filter. So your your Amazon event bridge is just confused what source it should accept. All right, just click on mitigate and then just say override trigger events and click on accept change. Right? See, this is the one it's going to pick up now. Fine. Now Lambda function. Just say create Lambda function. So our Lambda function name is this what has been completed. The event bridge rule has been completed. Now let's create the Lambda function. So I'm going to keep the Lambda function name as GuardDuty AI Analyzer and then paste it. So I will say Python 3.11 and additional settings, custom role execution, and then I'll say create new role because whatever logs have been generated by the GuardDuty, that needs to be like, keep in a proper format. Regex pattern and all, it should follow, right? And then it should send a Slack notification in a proper text. It shouldn't send the raw files because a raw JSON file is quite like, tough for us to read. So what we are going to do is we are going to give Bedrock full access here, right? Amazon Bedrock full access. This is the one. So in the background, we are going to use one Amazon default model, which is called Nova, and that Nova model is going to, like, separate all the logs in a human readable way by using some of the import libraries in Python. We will see that code later. So Bedrock, just scroll down and simply click on create. So GuardDuty Analyzer has been successfully created. Just click on save. That's it. And then scroll down again. Just click on create function. So GuardDuty 3.11, yeah, fine. Just click on create function. And the moment you clicked on create function, go to the configurations. First and foremost, increase the timeout. This is very, very important. And then next, scroll down and click on environment variables. So click on edit, add environment variable, because if you see the code here, we are going to use the webhooks. All right, just copy this meanwhile. Guys, if anyone uh, couldn't able to understand what this Python code is, I would sincerely request to go paste in AI and understand what exactly it is doing. Okay, even I also generated from the GPT Flash model itself only. So even in the real time, uh, like we were working with different clients, right? So we also generate with the AI tools itself. Only you have to understand what exactly this line is doing or what exactly this line is doing. So if you are changing this, what is happening in the background? So that level of knowledge is sufficient. So in real time, what we do is when a requirement comes in from the developer or a stakeholder, we do have a dev and pre-live account. So we are going to test that until and unless our developer requirement meets, and then we are going to like create a CR and move it to the product if required. So, so please copy this and paste it in any of the AI tools and understand what this Python code is doing. So for now, if you watch here on line 217, we have a Slack webhook variable, right? So we need to pass the webhook as well, webhook URL. So just come back before pasting the, just go back to the code, just remove all the lines, then paste it and click on deploy. So now go back to the configuration, environment variables, edit, add environment variables. Now we need a Slack webhook URL, right? So first copy the variable. This is the variable we have given the code. Go back to the AWS code, paste it, and my webhook URL is this. So I'm going to open the chat as well. So create an app. I'll say from scratch. Then I'm going to say DevOps LX, or I'll say like this. CTM means cloud minutes. Workspace is AIOps only. This is the one that we have created initially for our Slack. And here click on incoming webhooks, and then click on activate incoming webhooks, and then add new webhooks. So this is my workspace, and I'm going to give the channel name as Saikiran. This is the one that we have already. Let me see. Oh, that one was not there. Let's do one thing. I'm going to create a new channel. Okay, I will say the new channel as electric cloud. Just click on next. It's public only, no problem. Just click on create. Fine. Now come back here and then just drop down. Just see the channel was there or not. I'll just refresh. Electric cloud. This was there. And I'll click on allow. And then scroll down, copy the webhook URL, come back to your laptop function, just paste the webhook URL here and click on save. Done. We were almost done with everything, guys. Code part was done, configuration part was done. If you go back here, logic we have applied, and now let's test it. Let's test it and see if It's really sending the alerts just in case if someone is trying to enter into an instance and installing mining applications or doing any abnormal activities, then our guard duty is going to rate that activity as more than 4.5, which is marked as severity, and those severity logs gonna come back to our not logs, those severity alerts gonna alert us in the cloud alerting cloud channel. All right, let's go back to your guard duty for now, and then click on settings. So the moment you click on generate sample findings, see read it here. Sample finding help you to visualize and analyze the finding types that GuardDuty generates. When you generate sample findings, GuardDuty populates your current findings list with one sample finding, meaning it is going to, let's click on summary. It is going to generate some random high, critical, medium, and then low alerts, guys. All right. So just go back to the settings again. Those were dummy samples, okay? Dummy one, not the real one. Click on sample findings. So if you go to the background, it's still loading. Generate, yeah, successfully generated. If you go to the summary, see 11 critical alerts. Okay, Kubernetes cluster compromise of EKS demo cluster, and then potential credentials. See, all these are critical alerts only. Now, if I go back to the Lambda, and if I ideally this should start posting to my this model, I mean, Bedrock model should be enabled with the help of our event bridge in the backend. We did a small mistake here. See, Lambda we configured, but we didn't call the Lambda here, and then we started generating the logs. So it is okay, no problem. Uh, Function. I'll just refresh here. So in the event bridge, you have to give the destination, right? So I forgot to give the destination. Don't worry. So GuardDuty AI analyzer and existing, yeah, role was already there, so no need to create. So anything else? Nothing. Just click on the create, and I'm going to say test create. Fine. Now our event bridge is also created, and let's generate the logs one more time. Go to the settings, generate sample findings, generate sample findings. Okay, sample findings have been generated again. If you come back to the Lambda, and if you go back to the monitor, I think, see, there are some spikes, meaning our Lambda function is working. So I will just go back to my Slack. Yeah, here it is. See, we were alerting. We got a Slack notification, critical alert, severity 8 by 10, guard duty, severity 8 by 10, account. This is the account number. See, the reason why I have mentioned account number is in real time, we have more than 40 plus accounts. Again, it is it depends. It's not same for every organization, but in our previous environment, we do have more than 40 plus AWS account. So we wanted to know from where exactly it is coming from. We can also do this with the help of inspector and guard duty guys, but in all 47 accounts, I cannot enable. So I need a mechanism or I need a system where it's going to monitor and pin all the numbers like account number, region, and the detected timestamp, and then what kind of issue it is, what kind of alert it is. See, it says phishing domain request here is a phishing domain name was queried by EC2, and then here is the instance ID, right? The moment the moment it comes like this, either immediately one of our cloud team member going to jump in and check, or like anyone from the cloud team. We were six members actually in the team, so anybody, someone who watches this, and whoever is in front of desk, so they are going to just log in and see what were these alerts. Look, all those alerts here. So we're going to get the alerts. Actually, you can still reduce these messages because I generated the samples randomly, right? With the critical findings random from the settings. In real time, you won't see these many messages. You are going to get one single message. Just because we generated here randomly, we got so many high alerts, 160 alerts. So, wantedly, intentionally, we were pushing it. But in real time, you won't see those many alerts. You will see less alerts only. So it would be more easy for you to watch, understand, and remediate such kind of issues. Tomorrow also I'm going to do one more activity like this. If you watch the architecture here, this is also part of ChatOps Slack board itself only. This has been implemented in our previous environment. So Usually developers are going to ping us continuously because they do not have full access on the cloud or monitoring or an answer or some other. So they are going to ask us XYZ questions. For example, if you see here, see developers, why did the build fail? How did I connect to the staging DB? Can you restart my pod? Context switching. See all this stuff they are going to ask, and these are regular questions that comes from developer, and we need to answer again and again. So to avoid that, what we did is we created one bot, and whatever status is running in our system, or the progress is running in our system, that response will be automatically going to the developers. The moment when they enter at the rate and then they ask the question, the bot will be involved. All right. So tomorrow we are going to do these tasks, and now this AI security threat detection, this has been completed successfully, and we have achieved whatever we required. All right. So now what we shall do is first I'm going to delete the webhook because it keeps sending messages to my, and then CT alerts. I will delete this app as well, which is not required. Done. And then lambda function. Just delete this function as well. This is event bridge, right? Actions, delete. So I deleted. Then event bridge. I think here we don't have the event rules. Yeah. So just click on dashboard, rules, and then delete. Make sure you're cleaning your infrastructure, else you're going to get a lot of bill. Event bus. Let's leave the event bus as is. It is the default only, so no problem. And this is the most important node. It will cost you money if you're not suspending or disabling it. Just click on disable. Right. Great. We have deleted everything, guys. So thank you so much for watching, everyone. If you understand this and if you're doing the practice, make sure that you're posting it on LinkedIn. And again, on a soft note, see in production, you can easily implement this, starting with your lower environments, and you can put it on prod. And in the interview, if they're asking you anything, what were your contributions on AI, you can explain this task as well. Don't explain it in a way that you have did practice from somewhere. Explain it in a way that you already created an POC, I mean SOP, and then delivered it to the stakeholders, and it was approved for the implementation. So likewise. So that's all, everyone. See you in the tomorrow session. Have a nice day. Bye bye. Hello everyone, welcome back. My name is Saikiran. In today's session, we are going to do one more activity on FinOps Cost Explorer. Actually, before jumping on to the task, I wanted to tell you what exact standards I have followed in my previous environment first and what was a mistake I have did. So, if you're working in a cloud environment or if you're working as a DevOps or cloud engineer, you'll be working with a different team like development team and then QA team, full stack here, QA team, and also security operations team, the most important, and then network operations team, and also PCI team. If you does have any kind of data engineering team also, you might gonna work with multiple teams here. The problem here is none of them, again the standards will be different to organization. So here most of them will not be having any kind of admin access. Everybody will be having a view access itself only. So recently what has been happened is I'll be sitting here in the cloud team. So I was given a task by one of my product owner, or scrum manager you would say. So they asked me to onboard a tool called Vanta. All right, see, Vanta is actually an audit tool. So it does have some test cases in the background where neither you or nor anyone will be having a full privileges on those test cases. So Vanta does have some separate team. So they are going to follow some HIPAA rules or SOC security operations rules, PCI, DSS compliance rules. So they'll be having the full visibility on those test cases. Now, coming back to the issue, whatever I have faced, see, onboarding Wanda is okay, somewhat, not that difficult. We can onboard to somewhere around 4,000 resources. The moment I mention resources, meaning you can onboard to AWS, you can onboard to Okta, you can onboard to any of the VPNs, for example, OpenVPN. You can onboard to GitLab. So any resources you do have, you can also onboard to Outlook as well. So lot of resources you can onboard Vanta on this, right? So likewise, we were using somewhere around more than 20 plus tools. See, I have created some IAM users and then I also onboarded Vanta to AWS as well. What exactly this Vanta is going to do is Vanta is going to make our job quite easy, but the full privileges will be having for the PCI and then the security operations team. Privileges in the sense, like what percentage of security standards we were following and what kind of remediations we were getting. Are we getting any alerts? So such kind of visibility and all will be having for PCI and then also security team as well. Now I'll tell you exactly what has been happened. So Wanda is going to scan all the resources, for example, AWS or GitLab. I'll take two resource examples, all right? So here is Wanda, let's say. This is going to scan all the resources and identifies that any resource is facing public. For example, security group is facing directly to public. This is an Wanda issue. Or GitLab is not, users are not logging in with the multi-factor authentication, right? This is an issue. Likewise, Vanta is going to identify a lot of issues and it's going to write in a small alert message or email to us stating that, see, these were the resources that were falling under out of the compliance. Likewise, we got one alert, guys. So that alert is logging. It says we have somewhere around 40 plus AWS accounts. So Vanda has saying that, see, for all the AWS accounts, whatever I'm observing, logging was not enabled in real time. Actually, logging supposed to be enabled. All right, under CloudTrail, you can enable this logging. There are again two things here. One is management logs, and the other one is data logs. Data logs is quite expensive, and what Vanda is saying is And what Vanta is saying is you just have to enable this cloud trail logs on all these 40 plus accounts. But that will be a biggest disaster because it costs so much of money. The moment you enable logging, you know what will happen? Anybody who is getting into your AWS account and doing anything, each and everything will be tracked. Again, it depends on two things here. If you're selecting management logs, you'll not be having that flexible entries. But if you're selecting data logs, you'll be having more flexibility. Like you can observe what has that particular exposure user has put it. So what I did is instead of enabling Cloud Trails logs on all these 40 plus accounts, we have some product eight prod environments uh, in PCI security and then other environments as well. So I enabled only on these 8 accounts. I have enabled data logs. All right. The problem with this enabling data logs is in the background, you have to create one S3 bucket for storing all the logs. Either you have to create or automatically it's going to create. So here what has been happened every month we were getting, for example, there is an account called some XYZ account. Okay. This account bill was just $750 per month. But you know what has happened? Suddenly I enabled this data logs of these 8 accounts. This bill got doubled up $1,500 per month. As a cloud or as a DevOps or someone who is working in this cloud environment, sometimes won't look on this cost part because we are going to feed answers to the development, feed answers to the testing, feed answers to the uh, like you know stakeholders. And if any migration activities comes in, lot of activities going to comes in, we're going to jump here and there, right? I was assigned to do Vanta tasks. Every day Vanta is going to trigger somewhere around 700 plus issues on all 47 AWS accounts. And if you are also integrating GitLab or others, so it is also going to throw some alerts on these resources as well. So by working on all these tools like AWS and the remediations and other GitLab remediations and other EKS cluster remediations, I didn't worried about this cost. Of course, I calculated. I opened a ticket with one of the support team, AWS support team, and then I was just asking them how much would be the bill. See, they are going to give you some rough estimated bill, but they do not know what kind of resources we were running in the AWS accounts. That full level of access they won't be having, but they have given me some estimated cost. I also sent that estimated cost to my architect, and we also got approval from the architect and then stakeholder. And then finally, I enabled logging on this 8 AWS accounts, but the bill was somewhere around $1,500. Previously, that account does have a threshold of $750 itself only. And then the security team and then PCI team started asking me questions like why that was happened. So it was again a big mud fight. So I defended myself. See, I'm part of Vanta. I'm part of working on Vanta remediations. I worked. Whatever complaints remediations it is showing, I worked, and I also sent you the cost approval. My architect was approved, and my stakeholders were also approved, and then I implemented. And all of a sudden, due to the large resources we were using, so logging has been enabled on all those resources, and we got this $1,500 bill. It's fine. It's a valid answer. So, however, we deleted this logging because it is quite expensive for us. We have also other resources where they're going to consume a lot of money there. So we decided to disable this, and we had a call with Vanta team and said, see, we don't want to see this CloudTrail logging as an alert in the Vanta dashboard. And then we checkmark this, and then we moved it to the cancel state or resolve state, and then that remediation has been gone. Now here, just try to understand. So now the question is, let's keep everything aside. Why I or why other teams should wait till the bill hits $1,500? So security team comes with this question. We don't want like that. We want every 7 days or every 3 days. We want an auto-generated bills to our email. So bills in the sense meaning, for example, last 7 days the bill was consumed somewhere around $21, and they were expecting from cloud team that they need an automated email that what bill will be occurred in the next 7 days and how much it could be, rough estimation expected, or else, or if it is high, why it is high, that level of explanation they need. For example, we were using that, all right. So first 7 days, let's say somewhere that bill we got $8, $8.1 or something. So they were expecting something like after 7 days it should be $16.2, right? It the bill should be like this only for that. I'm just giving you an example, just try to understand. If it is going beyond 25 or it is going beyond $30, so the question is why? Why we got this much of bill? They need an explanation. And do we have any other remediations? Why you wanted to use NAT gateway instead? Why don't you use VPC endpoints? So that level of explanation also they need. So they need literally every 7 days they wanted to track what kind of costings are occurring on our AWS account, right? So we created, not we specifically, I created a custom dashboard where every particular point of time we are going to use event bridge today, a more event bridge rule based controls. So there at specific point of time like 8 p.m. UTC time zone every day, an email will be triggered to the security and then PCI team showing what was the bill and what was the last 7 days bill or yesterday's bill and how much is today's bill. All right. So that we are going to achieve with the help of Bedrock. Again, Bedrock is our foundation model. So before Bedrock, I'm going to create one Lambda function because I need some serverless activity here. And along with this, I am also going to create an event bridge because at every interval, I need a notification. So for notification, we need one more here, which is a simple notification service. All right. So this is what we are going to achieve today. So kindly do the practice and if possible, post it on LinkedIn. And let's go and do some practicals, guys. So, all right, here is our console, everybody. I'm in the Asia Pacific region. I'm not in North Virginia region, first and foremost. And if you go to the document, here is our document. Just go through the architecture and understand why we are doing this. All right, I've written everything here. And if we start with the part one, Cost Explorer and the SNS setup. So first and foremost, you have to enable the Cost Explorer. See, if your account is new, you can go directly from here, or you can also click on this, go to the billing, and then from the left side section, you can select the Cost Explorer. If this is a new account, I believe Cost Explorer will not be enabled. You have to enable it by yourself. All right. If you scroll down, Cost Explorer. Yeah, here it is. All right. So this needs to be enabled if you are using your account for the very first time. Like 1 2 days you have created, and then you have an option to enable here. But for now, it was enabled already for me. I don't need to enable again. And next step, create a SNS topic. SNS is again, everybody knows, it's a simple notification service. So it does have a lot of endpoints. It does have Lambda endpoint. It does have Outlook endpoint, email, Slack, and Teams. Lot of endpoints. So for now, today I'm going to select email endpoint. Right, simple notification service. So go to AWS console, SNS topics, and then create topic. And my topic name is this. Copy, just come back here, and let's say SNS, open it in a new tab. So just say daily FinOps reports, and next step, I'll just proceed with the standard itself only. This FIFO was not required. FIFO is actually first in, first out, which is quite expensive than this standard. So topic name, same, and then click on create topic, and you have to create the subscription here. See, I told you the endpoints, right? See, it does have simple queue service, data firehouse, and then Lambda, email, HTTPS, lot of endpoints are there. So I'm going to select email here, and I'm going to give my email. This is one of my, like, cousin's email, so I'm just giving this. I'm using his account. Actually, he does have a lot of credits in his account, so I'm just using his account. So just give the endpoint email here, and then just simply click on create subscriptions. So the moment you click on create subscription, you have to go back to your email and make sure you approve it. All right. So just click here under confirm subscription. Just click on it. Done. It's worked. Now just come back to the document again, and this step was done. Create subscription protocol email, and we have also provided the email as well. And save the topic ARN, not the subscription ARN. You have to save your topic ARN, because in the Lambda function we are going to pass these values under environment variables. And now the third part, which is creation of the Lambda function. So I'm going to copy this, and I will say Lambda. Just open a new tab. So just say create function. I'm in Mumbai, and just paste this FinOps AI Analyzer, and I'll take Python 3.11 and additional settings, custom execution role, create new role. We need to create one role, everyone. So just say existing policies, and what policies we need, I've written here. AWS billing access, Bedrock full access, billing access to view and understand what were the costs. Bedrock, what exactly it's going to do is the billings, whatever have been retrieved, it will be in the JSON format. That JSON report will be sent to the Bedrock. All this work will be done by our Lambda function. We don't need to do it again and again. And then SNS is for sending a notification to the respective teams, right? So let's select these three policies. So one, and then Bedrock full access, and then SNS full access. Just click on create role, and then scroll down, save it, and click on create function. So once the function has been created, make sure that you increase the lambda function timeout because this needs some timeout period. So I'm just giving 1 minute is sufficient for me. So I will just save this and also go to the environment variables, click on edit, click on add environment variables. Make sure you copy the topic ARN, not the subscription ARN. Just copy the topic ARN, come back here and then paste the value. So what was the key name? My key name is SNS topic here. And if you go back to the document here, see environment variables SNS topic here. If you give Control H, I'm sorry. So here we are going to call that as a variable in the Lambda code. See here it is on line number 140. All right. So just copy this code right from the beginning. Copy this. Just try to understand what exactly this code is doing, guys. On a soft note, this is going to pull the JSON file from the billing because billing read access was there. It's going to show the billings in a JSON level. You can also mention the time intervals here if you see in the line number 76. So for every 7 days I have mentioned. Now during this testing phase, we cannot wait for 7 days. If you wanted to reduce it, you can reduce, but instead I'm going to use an option here on Lambda, which is test event. So I'm going to use it and push some fake events and see how it triggers to our emails. So topic has been copied. Uh, just go back to the code and then just remove all the code and paste the new code, whatever you have copied. Just click on deploy. This is very small task, but the testing phase has taken a lot of time actually. Yeah, here it is. Okay, and then go back to the document. Python code has been copied successfully. Now we need to schedule. I told you right in the introduction that for every day at 8 p.m. See here, every day 8 a.m. UTC, it should write an email to my security team. All right, so that logic will be taken care by this Python logic. So automation execution. Now I'm going to go back to the Amazon Event Bridge, and here just open it in a new tab. I'll say schedule rule, not the event pattern. Event pattern is something where you have to select source and target. I'm selecting schedule rule here. Schedule rule and rule name I will say daily FinOps trigger. Description also I'll give same, and then just click on next. See 08 star star question mark star. Okay, follow that. That is actually part of cron jobs. If anybody comes from storage background, so it's a Linux feature actually where we can use cron tab hyphen e, and then we can run some schedule jobs. Creation of starting of instance, termination of instance, or collection of log rotation. So all these are part of cron activities. So now just go back here and just say 8 a.m. and here I'm going to say 0 0, not 0 0. Here we can give star actually, not 0, star question mark star. See, every day Monday 30 31, I mean Thursday 3rd 4th 5th 6th 7th, likewise every day at 8 a.m. UTC. All right, so done. Just click on next, and then it's going to ask what was the target. My target is lambda function, so just give lambda function here. And what was the lambda function? This is my lambda function. Select it, scroll down and click on next. No tags required for now, so I'm just clicking on create rule. Done. This part is also done. Now comes the important thing, which is testing. Right, this sounds like very easy. Honestly, I'm saying we have taken almost 4 or 5 days to design this and deliver after repeated testings, repeated changes and all. So I have explained it in a very simple way, less than 20-25 minutes. So you can do the practice and In interview, if anybody is asking what were your contributions on AI, just try to explain the whole task, like what you have faced and how did you fixed, and how you automated that a custom dashboard has been created and sent an email to your respective team every day. So let's do the testing now. Go to your Lambda function and click on test. We have a test feature here on the Lambda function. So I'll just simply say test it. Okay, it was succeeded status 200, report sent. Now I'll go back here. I'll open my email. See, I got the email here just now, 0 minutes. It says daily AWS FinOps report. Even if you wanted a colorful text, you can still use simple email service so that it's going to send you some HTML emails. And also you can add a small line into the Python logic and yeah, it triggers an colorful logs like red is danger, green is good, blue is like something like that. So daily FinOps report for the period, if you watch here carefully, 2026 6/21 to today is 28, right? So between this, what was the bill? So here it is. See, now it is showing zero. Actually, it is expected because we were in testing phase. But ideally, in Python logic, if you see, we have scheduled it for 7 days. So when you do it in your test environment or any pre-live or pre-prod environment, then you see the actual values here. But for now, everything is expected. We were receiving an email as well. So top service cost, like what was the service that has used highest costs and also any anomalies detected. So it's going to mention that here. And what were the remediations or recommendations? I told you, right? For example, NAT gateway. Why we are using NAT gateway? Instead of that, to reduce the cost, we can use VPC endpoints as well. Likewise, see, implement detailed cost tagging. Ensure all resources are tagged costing allocations because I didn't tag any of the resources when creating. So that's why it is asking us to add some tags. Enable cost and usage report. So this is again um, some billing charges will be there for this, so I don't want to enable it. But if you wanted to enable, you can. And then set up cost alerts, configure CloudWatch billing alarms for the thresholds. So again, these are all part of remediation itself only. So this is what they were expecting, the dashboard where it shows uh, like what was the usage previously and what we are using now and how much is the cost and what were the remediations. So I hope you understand. If you really like the video, just hit that like button and also subscribe and share this video to most of your friends, whoever is in need. In interview nowadays, they were asking very common questions. What were your AI contributions and have you used AI in your previous environment? If you're using AI, what foundation model you have used? So all those things will be asked in the interview, guys. All right. And on a soft note, many people were confusing actually. I just wanted to show you my Cloud Vishwakarma portal. Many people have pinged me as well on LinkedIn. So they were watching this YouTube videos, first 10 videos on 10 AI tasks, and they were asking, is it enough? See, I have said already in the first video that in the courses, if you go here under Cloud Vishwakarma portal, if you click on AIOps, here we do have some prerequisite, guys. See, all these were theory part, but again, I'm not forcing you to watch it. But if you are interested, then watch it. If you're not interested, you can ignore. So the 10 tasks, whatever were there, those were actually 20 tasks. So first 10 will be posted on YouTube and another 20 will be posted on my Cloud Vishwakarma portal, and these were specifically available only for the mentorship students. So if you wanted to opt mentorship or self-paced learning, then you can click on this pricing and you can watch everything here. All right. So previously the mentorship is only for 40 days, 45 days. Now it has been increased to 60 days, and lot of things have been changed here. Every day I'm going to connect at 8:30 p.m. It's only me. Nobody is going to connect. Likewise, what exactly we're going to do these 60 days? We have a certification block here. So these certifications outside, if you go and do it, it will be somewhere around $1,186 to be honest. But here it is free for my mentorship students. You just go select whatever exam you wanted to test yourself and then start attending the questions. Likewise, we have GCP and then also we have Azure as well. All right. So I hope everybody understood the task, whatever we have did today. So just do the practice and post it on the LinkedIn. Make sure you're deleting each and everything. First and foremost, I'm going to delete the subscription. Don't delete the topic directly, it won't work. So delete the subscription first and then delete me. Oh, sorry, delete me and there is no space. And then FinOps function, select it, active delete. I'm not deleting the IAM roles because it won't cost me anything. So I will leave as is. And then event bridge schedule rule, select, and then delete. That's all. Whatever we have created, we have deleted. Make sure to do the practice, don't just ignore. Thank you so much, everybody. We'll see you in the tomorrow session. Bye. Hello, everyone. Welcome back. My name is Saikiran. In today's session, we are going to do one more real time activity on something called KEDA. KEDA is actually Kubernetes event driven architecture. But before jumping onto the task, first try to understand the problem statement, what we have encountered during the time of working on one of the famous medical insurance based company. All right, they do have a system, guys. This system is nothing but an AI powered document processing systems where people are going to upload the PDFs and people are going to upload the invoices and people are going to upload any of the bills or like acknowledgement claims or any hospital bills or any random documents, either if it is in PDS or Excel or some stuff like that. So our users do not have an access directly to our AI powered system. No, instead they will be uploading all the data at certain place. The moment they have uploaded, all the data will be managed by one of our queue service called SQS, which is simple queue service. This queue acts as a buffer between incoming requests and worker pods running inside the Amazon EKS. All right. On an average day, during the time of night, we hardly see only 5 to 6 uploads. That's all. All right. This is okay. But during the daytime, we see somewhere around customers are uploading 900 or 900 plus documents to our system. So for this kind of behavior, Kubernetes is providing something called horizontal pod autoscaler and then vertical pod autoscaler. That we know. And how this Kubernetes pod autoscaler and vertical pod autoscaler works? It works on metrics, right? Either CPU metrics utilization or disk utilization or memory utilization, let's say. But I am not running any kind of web app here, right? I'm not running any kind of web application. I'm running something which is part of event driven. There is no server in the background. And horizontal pod autoscaler and vertical pod autoscaler does have some components like max capacity, minimum capacity, and then design capacity, right? Under max capacity, you can keep 0. Design capacity, you can keep 0, but minimum capacity you cannot keep 0, you can keep only 1. But when you're working on an event based architecture, when customer is not even uploading a single file during midnight like 2 a.m. or 3 a.m., why should I keep one instance at least, or why should I keep one pod? Because the minimum is 1. I cannot make it to 0. Why I should keep one? Again, it's a cost problem for me. This is one of the issue we have faced. And the second problem here is with the horizontal pod autoscaler or vertical pod autoscaler metrics, because Kubernetes doesn't know who is SQS here, or horizontal pod scaler doesn't know who is SQS here. Both Kubernetes and then horizontal, all these components run only on the CPU metrics. But in the daylight on our SQS, I have, let's say, somewhere around 5,000 jobs pending behind, because my CPU utilization is normal now. It's only just 1% because Kubernetes metrics or Kubernetes CPU utilization doesn't know that SQS is holding these many jobs behind. All right, and CPU utilization is only just 1%. So based on these metrics, my horizontal pod autoscaler or my vertical pod autoscaler is not going to pull the instance to work on this 500 jobs that were waiting in the SQS. So this is where the problem comes in, and customers also face a lot of issues, and they might see a lot of time is taking for our AI system to generate or to extract the information from this 500 PDFs, whatever were there in the SQS. So to beat this or to achieve this, we are going to do an task on KEDA. KEDA is a Kubernetes event-driven auto-scaling where this is not going to monitor your metrics. This is not going to monitor your metrics. Instead, it is going to monitor your SQS, guys. All right, this simple queue service. You can also implement KEDA on other services as well. For example, in AWS, we do have something called SQS, and also you can implement this on Kafka and Zookeeper, and also you can implement this on Azure Bus, and also you can implement this on Redis. So this is going to monitor these queue services, and then it's going to speed up the pods accordingly. And one of the best advantage using this SCADA auto scaling is it can degrade or it can downgrade the instances to zero. This feature is not available in the Kubernetes horizontal pod autoscaler. No, because horizontal pod autoscaler can only reduce the instances to one, not to zero. Zero is not possible. How this SCADA is going to behave is it's going to calculate. For example, if you're giving, you pick up one pod for five jobs. So five jobs. So let's say, example, you are getting 10 jobs. So automatically how SCADA will behave is okay. For five jobs, one pod. So 10 jobs, I need to pull up two pods. Likewise, as many as jobs increases, it is going to automatically spin up the AI pod workers in the background. So I'm going to show you everything in a practical way. Then you will be understanding it more clearly, guys. So let's go and do the practicals, everybody. So this is our console, everybody. I deployed the EKS cluster on USC One with the help of Terraform, and I uploaded all the dependency files here, standalone EKS, where you find the EKS cluster deployment, and then also you will find the GitLab deployment here with the help of Terraform. All right. So every time we cannot create manually, right? So we can spin up fast with the help of Terraform. So if you go back to the documentation here, so also I deployed one service account. I'll show you what service account I have deployed. So it should be under Cloud Formation Stack. So I'll just open a new tab. Not sure why this has been taken a long time. So I also deployed this before coming to the session. This service account is related to the KEDA, where it's going to access the required resources, whatever we need on the AWS side. All right. So if I open the documentation again, make sure you're watching all the Y factors and the architecture here. So first and foremost, step one, you need to deploy one EKS cluster and make sure you are setting up the context with the help of this command. Right. So once that is done, then deploy one IAM role for service account for KEDA, and this is it. Create IAM service account, and this is my cluster name, and this is the name of my KEDA operator, and namespace is KEDA, and the policy is going to be this. So if you wanted to know what policies I have attached, see, this is the one. Amazon SQS read only access and approve hyphen role EKS SCADA operator. All right. So this service account was also deployed successfully. Now step two, install KEDA via Helm charts. So we install KEDA using the official Helm chart and link it to our existing IAM role based service account. Nice. So just copy these two commands and just paste it here. So this says already exists because previously I did some testings here. So that is the reason maybe it is still there, but it is okay. Now let's install the Keda on the namespace here. So helm install Keda, and then this is the package name where we need to deploy. And on namespace is this Keda create namespace, set service account operator is equals to false, because if you see here, we were already creating the service account here, right? So that's why we have kept as false here. Hyphen hyphen set service account operator equals to CAD operator, and this is my service account name. So I will just copy this and paste it here. Sorry. Enter. So here I have written clearly wait for CAD operator pods to reach running state. So to check that, you can run a kubectl get pods hyphen and CAD hyphen and meaning namespace, and then in this namespace, you're going to see two pods running. Okay, it shows, let's run this kubectl get pods hyphen n. Oh, I've entered the wrong. Yeah, see, these were in the running state. Slowly, it will also turn to the running state. So, no problem. Let it come. Let's not move to the next step until and unless you see KEDA is working properly. So it's going to deploy three pods. One is for webhooks, other one is for metrics, and this I'm not sure. Just try to explore what exactly it is. KEDA operator. This is the pod name. There is no specific name here. So let's run the command again. Yeah, all three were running now. If you come back to the document here, so this step is also done. Now, infrastructure. What we need to do, we need to create one SQS. As said in the introduction, a lot of PDFs will be uploaded, right, by customers. So that queue will be managed by this SQS itself only. So I'm going to go back to my AWS console and I'm going to create SQS. So let's say SQS here, simple queue service. We also do have another service, but both are different. One is SNS, another one is SQS. So I will just click on create queue and paste the queue name here, AI task queue. I'll just name it like this. Let's not do any changes, just go with the standard itself only. I'm not going to click anything later, and then I'll just click on create queue. Once after the queue has been created, make sure you're copying this URL. So later we do have some work with this URL, because we are going to deploy a service of or a resource of authentication method using manifest files. Then we need this URLs. So I'll come back to the document again. So this is the URL. I ask you to save it somewhere carefully. And part 3, application and autoscaler YAML. So deploy the dummy worker. Dummy worker meaning we need one pod, right? Or we need a job that scales completely to zero. See, here I mentioned here replica sets is equal to zero. That's the speciality of this SCADA. It's not one. In auto scaling groups, you cannot keep zero, guys. You can keep uh, minimum as one itself only, max, minimum, and then desired capacity. You cannot keep everything as zero. You can go and check it or else. If you wanted to test, you can go back to the cluster, get onto the cluster, just click on compute, and then if you come back to the um, compute node groups, and if you click on edit, just try to keep everything zero here. You cannot keep, minimum size should be one at least. So these can be kept as zero, but in Canada it's not like that. You can keep completely a zero here, the replica. So now, so one worker will be deployed now using the deployment file. This is the manifest file. So why I'm deploying is later I'm going to pass some SQS queue jobs. So immediately this worker should come up. We need one worker, right? So or a job or a pod. So that's what it is. So I'm going to copy this deployment file and copy this, and name it as worker-deployment.yaml. See, if you watch carefully here, kind is deployment, name I'm taking it as AI worker, replica sets for 0, and containers image, this is the basic image I'm taking. See, I have written a dummy script that just sleeps pretending to process queue items because it is just going to sleep while true do echo pulling SQS sleep for 10 seconds done. So this pod is not going to do anything as of now. This will be completely idle. The moment you pass some jobs to the SQS, and this is going to come up, and it's going to spin up some pods. Okay, so now this file was already here. If you watch carefully, if I say ls-al, see this. Oh, I'm in the different folder. Okay. And on a soft note, everybody, please don't depend on the numbers, whatever you're watching here on the left side. Only follow the numbers, whatever you're watching on the repository. All right. Because sometimes we need some high band modules or high band models of a sales maker or something. So some of the tasks, whatever I left over, those were not supporting those models. Actually, even if I asked for AWS, they were not allowing me to enable on the pay as you go as well. So so just don't follow these numbers. Whatever you see here, just follow only the GitHub repository, whatever I'm uploading here. Good. Now go back to the document again. So I will just copy this simply and just Control C, and I will say nano worker deployment dot YAML, and then paste this here. So Control X Y kubectl apply uh, worker deploy dot YAML. This has been deployed. If I say kubectl get pods, nothing should be running actually because the replica set here is 0. Even if I check on hyphen default, see, nothing will run because the replica set was 0 here, right? So now step 5, create the KEDA scaled object because this custom resource definition, which is CRD, is what connects our Kubernetes deployment to the AWS SQS queue. Okay, just like how we have a different resource like deployment, a different resource like secret, we also do have a different resource type like trigger authentication, right? So I will just copy this again. I think you have to do some changes here. So kind is trigger authentication on what? The name is this, namespace is a default, and provider is AWS. This has taken more than 1 day for me to fix. So I just followed AWS hyphen operator here, but that's the oldest tradition. This is the new update. You can mention only the provider name AWS, Azure, or GCP. So AWS, and in the second manifest file, we have a scaled object resource, and that is specifically targeting this AI worker node. See, whatever pod or job you are creating here, so this scaled object is targeting that worker, I mean, that pod. The moment workload increases or queue increases in my SQS, so the minimum is 0, which is scaled down to 0 and idle. Maximum is 50. 50 is more than enough, guys, to be honest. So this is the cooldown period for every 60 seconds it's going to watch. And polling interval is 10. Check query every 10 seconds. Wait 60 seconds before scaling back down to 0. Yeah. All right. So minimum max polling and then cooldown period here. So make sure you are pasting your queue ID, which have you seen in the URL block here. So I will just paste this and save it. Queue length is 5, target 1 pod for every 5 messages. Okay, all right. AWS region is not AP South 1. I'll do one thing. I'll just copy this, Control F, and then I will say US hyphen east hyphen what. So I'm in North Virginia, right? So I just changed everything, just save it. So I will just copy this again. And what was the name you wanted to keep? Scaled objects, right? Yeah, we can keep it as scaled objects. Nano. Just paste everything here. Control X Y. Apply hyphen F. Yeah, this has been deployed successfully. This is not a deployment, guys. Don't confuse. One thing we were deploying the scaled objects, the other one is trigger authentication. All right. So if I scroll down again, now we have to test it. Test whether the auto scaling is working properly or not. See if you enter kubectl get pods, it shows nothing, right? If I enter hyphen namespace default, it shows nothing. Now I'm going to pass some fake queue messages to make sure it is storing in my SQS queue. See here, inject load. Why we will artificially send 100 messages into SQS queue to stimulate a massive spike in the user traffic. So we were just running a small for loop here for I in range of 1 to 100. Do send messages hyphen f in query hyphen URL. So to this URL, you just send 100 messages. Okay, nothing else. Just copy this and I'm going to paste it here. And is my URL correct? I think I didn't change the URL. Let's change the URL first. This is my SQS URL, and great. Now copy. See, it is going to send some uh, 4, 5, 6, 7. Likewise, it's going to send some 100 messages within the 10 seconds or within 60 seconds, whatever the time frame you're mentioning here. It's going to go and watch the SQS queue. The moment it identifies a huge workload, automatically we have created one worker pod here, right? This worker pod. Initially, when we are running these fake messages or artificial messages to SQS, the jobs were zero, no pods, nothing were running. Now I'll just give Control C. Watch carefully, and then I will just say kubectl get pods hyphen default. So let's wait for some time. Immediately it won't show. Let's wait for some time and see it's going to start spinning up the pods. See, if you start here, I just ran one kubectl get pods watch command, and it is start like pulling the pods. Pods were deploying in the background based on the workload, whatever we have sent artificially. Now I'll do one more thing here. So I will just delete this again, and then I'll just copy, just give Control C and paste it. So slowly, if you watch carefully, all these running jobs will be terminating now because I'm clearing up the SQS space in the background. Whatever jobs you have pushed it to your SQS queue, slowly all the jobs will be terminated now, and then also our pod is going to go back to its original state, which is zero. Right? Just watch it. It's going to take a little bit of time. So if I run kubectl get pods again, maybe I think this command is wrong. Let's correct this. I will just use agent. Please wanted clear the queue. So let's run kubectl get pods. Yeah, see, it is terminating. The command is correct actually. No need of using the agent. If you watch here carefully, it is terminating now because all the queue, whatever was there in the background, it has been cleared. See, no resource found in the default namespace. It went to zero, right? Now I'm going to pass the jobs again. I'll just copy and I'll paste it here. Enter. Now it is passing some more jobs to our SQS queue. I'll just say Control C, and now if I enter kubectl, you'll get ports hyphen and default hyphen W. So just keep watching. See, it start pulling out the ports again. So this is how it works, guys. So just directly do not implement this in your prod environment. Just in case in an interview, if somebody is asking what were your contributions to the team, and then start explaining this, because see, nobody is going to go back to your experience and check whether if you have really worked on it or not, but you have practiced at least. So you can tell them in a way that in our previous environment, I work for one of the medical insurance client. So you can also tell the client name if you want. The Cigna Group, they work a lot of PDFs extracts and then Excel sheets, a lot of things because it's a proper medical insurance based organization. Um, the moment user uploads the file to one of our AI bot, so immediately it should extract the data and keep the things as is. Like in database, we do have some customer names, or customer data, or you can customer data in the sense not the meta information, the policy information I'm talking about. And the moment customer don't uploads anything, we keep everything to zero using keda. Previously we used to get a lot of costs using a horizontal pod autoscaler, because in the background, even if the customer is not uploading any data, even if the status is idle late midnights, but still the minimum capacity still used to run. So that is giving us the cost, and we reduced it by using this service called keda AI, right? So all good. Now let's terminate everything. Um, I'm in standalone case. I'll just terraform destroy. So this is going to destroy my whole. Okay, it's destroying. So meanwhile, in the background, make sure you're deleting the stack. Edit termination. Deactivate. Save. Delete stack. So I'm gonna delete my service account. Copy. Delete. And I'm going to delete this queue as well. So that's all, everybody. Please do the practicals and post it on the LinkedIn. We'll see you in the tomorrow session. Have a nice day.